Hey y'all, how's it going out there? Happy Sunday night. I know I said I was only going to be here every other Sunday night, but it's the internet. Truth is meaningless. Hi, I'm Jeff. Most of you know me. I assume if you're watching this, you found it because you know me. Maybe you're not. Maybe you're like someone random out there on YouTube, in which case I hope you'll say hi and tell me who you are. As most of you who are watching this know, at least Chris, hi Chris, I don't know who's watching, know that I do classes on Sunday nights on Arduino and Raspberry Pi programming, and it's gone to every other week now that I'm back at work full-time on site, which is a great place to be. But I figured this Sunday night, kind of on the off week, I would share a personal project that I have going on, which is these, here, I'll show you, these tiny DMX-controlled moving lights that I've been working on off and on for, frankly, for ages now. I'm ready to endeavor on the next version. So I thought it'd be fun to get on and try building it live. I used to do a bunch of these. I used to just do this process live. I feel like, Chris, you were probably here for a couple of those live streams back in the day, whenever there used to be days. But yeah, I thought it might be fun and to chat about where the project is and where it's going, and what the problems were that we had come up, things that were issues in the previous version that hopefully have been solved. We'll probably find some new issues today. I have one that I've already found. So this is not the very first build of the PCB. I assembled this one just before I shot the last YouTube video that I put out in version 0.9.1. So I know the PCBs in general work, and for those who didn't see that video, there was a problem with these PCBs that I ordered and had assembled by JLC PCB in China. Let me zoom you more in there. So you can see that all the little black resistors here are kind of cattywampus, in contrast all the chips that are very nicely soldered, and that's because I accidentally specified that instead of being stuffed with 10 kilo ohm resistors, that those should each be stuffed as green LEDs, which doesn't work nearly as well. So I went through by hand and removed all 110 of those LEDs and replaced them with resistors. And it's not as bad as it sounds, because those, both the LEDs and the resistors, when you're buying a whole roll of them, cost about a cent a piece. So it's not a huge material loss. It's just, an investment of time that I had to put in. The resistors, for those who may not have played with Surface Mount before, and I'm gonna try not to have too much tummy cam this evening, but it may be somewhat inevitable. So when you order Surface Mount parts, when you order them as a factory, they come on a big plastic spool. I actually don't think I have any of them terribly handy. But when you order, I don't want a spool of 30,000. I want just 1,000 of these to play with. They come in a package like this from DigiKey, and they come on this little tape. And the whole point of this form factor, let me see if I can get you to focus there, and not be totally blown out. The whole point of this form factor is this can be grabbed by a machine and fed in, and the machine automatically peels back this top, very lightly adhesive tape. Let me see if I can adjust the exposure of this. Oh, I see. I had the camera deliberately overexposed a little bit. That's why it was overexposing. So the machine would peel back this tape as it goes, and then a suction arm would come and pick up each individual resistor, place it down in the spot on the board, and then would go through an oven basically and bake the solder on the board all at once to slightly melt it, and that's how you get your machine soldering. Chris, yeah, it's a fair number of resistors. I figured, 10K resistor is such a common value. I've lost it already. 10K resistor is such a common value that I figured I would use it. Oh, hey, Nate, how are you? Yes. Yeah, Nate, kind of a bonus electronics bash. Really just I felt like being on a Sunday night would be fun. So it's really just going to be, I'm just talking about this Demilight, this personal project, as an excuse to build the first fully assembled model of version 0.9.1 and see what goes wrong. So I guess sort of I referenced earlier that I had already found one issue tonight, so I got a little bit ahead of myself. I thought it'd be fun to go through and build all these circuit boards and build all the components one by one, and we could discover the issues together. Wouldn't that be fun to do online on a Sunday evening? I already found one issue. And that is, well, first, let me explain what all the components are, because I've laid out all the components for a single light on the board here, sort of on the workbench. I have components to do 10 full boards, I think, if I don't break anything. But here's the components for one. I'll talk you through them, and then we'll go ahead and start assembling this, and we'll see what we learn. As always, like, this project sort of spans a wide gamut of things, so like ask questions as they come along. Otherwise, I'm just going to ramble about things as I do them and like parts of this process. So I don't know. This is just like, I think I said this last week or a couple weeks ago. It's like, I'm going to try this more casual style. I haven't really prepared for what this is other than laying the things out. So call this an electronics cache. That's not going to stick. We're going to workshop that a little bit. All right, so parts on the board. Let me zoom in a little bit there. So these are the parts of a single Demilight, a single tiny moving light. So we have 6 3D printed parts. We have this base unit here, which has holes for the power and data connector that we'll look at in a second, and a hole for the Pan Servo to go in. We have the lid to it, which sort of slides in. Let me get a little bit of flashing off there. It slides into this slot here, and it's just a pressure fit. In fact, I'm probably going to have to file this down a little bit. I originally, when I designed this bottom case new for version 0.9, I had like a pop-up tab that would sort of bend in and out, and as you press this in, it would snap into place, which I liked, but it wasn't super robust, especially printing in this orientation. You know, anything that's going to have layer lines going this way is going to want to tend to, as you put pressure on it, like so, is going to want to snap at one of those layer lines. So I eliminated it because it wasn't really doing anything. And now it's just a press fit top, which seems to stay in pretty well. So that's 2 pieces. We have this Pan Servo cover. So once this lid gets put on, we put the Pan Servo on top, and then this is just an aesthetic cover to cover that up. It's actually still got a little bit of the flashing from the 3D printing process on there. And then we have the 2 halves of the body. And these have gone through a ton of revision over time, especially how the 2 of them hold together. But I added some additional tabbage to the right-hand half for this one. And so now they press fit together really quite well. You could always put a little bit of adhesive on there. Chris says need an SLA printer for some. You know, I don't know much about layer-to-layer adhesion on SLA. I know SLA is not necessarily known for its mechanical strength after the fact, but I don't know in this case, like I don't really need strength, I need layer adhesion. So the 2 halves of the body, and then I have the little yoke, which attaches that Pan Servo to the body there. So when it's all assembled, the basic form factor of this is like a version 0.7, 0.6 light, but this just gives you a sense of what all those parts are. The base, lid, cover, yoke, and 2 halves of the body. This has been quite a test bed. Palmer, hi! Yes, exactly. We all need strength these days. Yeah, I'll take strength between layers, strength between communities. Yeah, anyway. So getting into like the electronicsy parts here, I guess technically there's 8 3D printed parts if you include the hanging hardware. So the idea is that these would mount into little threaded inserts on the base here, on the cover. Yeah, the whole Sunday crew is all here. I thought about like sending out a thing, but I wanted these off weeks to kind of be casual. I feel like, if people see it, they see it. If they don't see it, they'll see it. Hi, Josh McCammon. Nice to see you. Josh is a really cool sound human. Josh actually does some really cool stuff showing how you can use, especially like how you can make your sound better, which I super appreciate because I am not a sound person. How is it the unannounced stream has more viewers than the scheduled? I don't know. I put it on like my personal Facebook, and Twitter, just to be like, hey, if you want to see some nerdy stuff that I do, here we are. So these hanging hardware, these J brackets, will mount a threaded insert in here, and then we'll screw this in. So I guess if you include those, we have 8 3D printed parts. Those are meant to hang off of a little 3D printed truss that I designed, a little adorable 3D printed triangle truss. You can see the orientation these are printed in, and that printer has a little bit of problem with bridging. You can see those loop-de-doos, and this is printed this way up, and there's some little hanging loop-de-doos hanging underneath there. So maybe when this is all done, we'll hang it off of this light, and I can move the nice camera, and I can see it dancing around in action. Other parts before we start assembling them. So obviously the control board, and we'll talk about that in quite a bit of detail tonight because, well, we're going to be using it quite a bit tonight. We have the LED emitter chip itself. So this is a 10 watt, what they call a 3-up LED star. That 3-up nomenclature is branding by LEDsupply.com, which is the vendor that I get it from. I bought a bunch of these when they were on clearance, and because they're kind of expensive in unit quantity. But you can pump out, an amp through these things. And the heatsinking holds up okay. One of the things I will need to test before I release these designs to the public is can you put an amp through these things and leave it in this 3D printed enclosure with no additional heat sinking and have it not melt the light? And I'm not entirely sure what's going to happen. Chris, I know you were here for when I was burning my hands with 6 or 7 amps on an LED last year. But the goal of these would to be to not burn or melt things. Yeah, we'll do some fire tests again. I guess the only remaining components. Oh, one of the cool things about these products from LED Supply is focus there. Yeah, so you can see they have these 3 little mounting holes. Those mate to these little adorable lenses from a company called Carclo, which LED Supply is also a vendor for. So you can have this singular star, but within that, here, can I zoom in anymore? Yeah, oh yes I can. So within that, if it'll focus, yeah, you can get different lensing for your LEDs. So I have some narrow, some medium, and some wide. And they're never going to be a super sharp beam, of course, just because they're 3 separate LEDs and it's a plastic lens at the end of the day. But it's cool to have different lensing options. And these lenses are super cheap. They're 80 cents a piece in quantity 1 and less in larger quantities. So those are super cool. And then I have some headers and some things we'll be using for soldering things to the circuit board. So that's the gist of what we're playing with tonight. I'm drinking what are you? A delicious IPA from Stone Brewing Company. It's part of their no stone unturned pack, which the gimmick is all the labels are upside down. So hence why I had to turn my head around, which is pretty goofy. If anyone's drinking anything fun out there tonight, always super curious. If it's just water, hydration is also important. No pressure at all. Josh, I know, is a man of a cocktail. And a cocktail of a man. Dumb. So why don't we dive in? Where do we buy the kits? So here, why don't I start assembling a thing and I can answer that question as we go. So my thought is, because one of it's not really meant to be a product, right? Or I don't intend it to be yet. It's just kind of a fun thing, and I think it would be fun to be able to share this with others. And now, I should show you the table. There we go. Now that we've gone to a really surface mount environment, and they're getting machine assembled, when there was all through hole, I was like, okay, I could release the plans and probably people could assemble them. And now that it's a much finer design, I don't feel... I will release the designs, but I feel like giving people a surface mount kit of this size is not really great planning. So what I thought I might do is build, do an order of 25 or 50 of these boards, and then your kit comes basically as you saw at the beginning of the video on the table. You get the electronics and the hardware, you do a little bit of through-hole soldering, and you assemble it yourself. I think I would also, I think it would be here's, the 3D printed parts are available for free as a design online. All the schematics are open source. If you wanted to source all yourself, you certainly could. But I think as a thing to I don't know, put on Tindy, it would be a circuit board, a couple of servo motors, and also all the electronic parts you would need. And you'd print the parts yourself on your printer at home and assemble the light from there. That's kind of my thinking. Chris, Nate, J. Paul, and you all have experience building things. Does that seem plausible? What am I forgetting? What sounds not, what could be better there? Oh, thanks, Nate. Yeah, I made a little sign for behind me here. Build, test, repeat. To remind myself this is it's all an ongoing process for sure. I also, I should show you, you might see as I move my head around here, the other new feature in the workshop today, that I can, you can't see most of the time. Which I realize it's the perfect spot on the wall, but it's buried by my head when we're here. That's from a really cool store that's since defunct called Weird Stuff Warehouse in California. I put that up on the wall behind me. James, I buy the kit. Yeah, for sure. Yeah, I'm really interested. So I have a couple of well, I was gonna say I know a couple of nerds. We're all in good company here. I know a whole list of nerds in the chat this evening for sure. Oh, you know what I need? Sorry, quick tummy cam. I have a couple of people who have volunteered to be my beta testers, and I know that they have a pretty serious 3D printing setup, or I should say a pretty well quantified 3D printing setup. In the sense of, like, they have something like some decent like home printers that they know the parameters of, and so I feel good about saying, like, here's, you know, I printed this on a couple of different printers that I own. Will you try printing it as you would on your printers and see if, you know, are my tolerances still useful for your style of printer? Because that's one thing that I've found is that, so some of these parts are printed on my Maker Select V3 at home, and some of them I've been printing on the Prusa Mini that we have in our workshop at work, which my boss knows about. It's all above board, but that's a very nice little printer. And so I'm really curious, like, you know, the tolerancing for some of these, I'd always rather go too tight and people can file back a little if they have to, I think is the way to go. But I'm interested to see how other people with their other, especially like home hobbyist printers, like how those things turn out. Let's see. Chris says maybe an option to buy just the boards. Could totally sell just the boards. Maybe it's like the board. I feel like, you know, the most like economic or like efficient thing for me to do would be to sell you a kit. I don't want to sell. I don't want this to become like a business, but I'm just like, I'm cool. I think this is a cool way to get it out there. I think the least labor intensive way for this to still be cool would be like, I'll sell you, you know, the thing with the the board and then like the through hole pieces, and you have to solder on your own headers. And there's like 4 of them, and we're gonna do them right now. You'll see it's really nothing. Palmer says, any of the prints over 4x5? No, the largest print is the base, and it is like, I want to say it's like 40 millimeters by 40 millimeters by 25. Nothing is huge. If you print them, you know, if you wanted to print them in a full sheet, if you have a larger printer, like I can print 9 on my bed at my once. I print 9 at once, just for like time efficiency. So you do gain some like ability to print more at once, but no, none of the parts are particularly big. All right, I think my iron is finally up to temperature here, and I can actually solder these, which would be fun. So what I am soldering now is the power and data input connector, which is going to bring both DC power and just raw DMX data into the light. It's a little 4-pin right angle header here. It's actually, I should have checked alignment before I finished soldering it in. Chris asks, are the red prints from the Prusa or the Maker Select? Actually, they're half and half. I started on my home printer, and then I took my, one of the things that like I try to do is if I'm printing personal stuff at work, they ask that like you bring in your own personal filament, which is totally legit. So they're half and halfy. Some of them, I'll show you. So, like these bodies, these final body shapes are definitely on the Prusa Mini, and they came out really, really nice at the end. Things like this body were printed on my home printer. Now, to be clear, this was one of 10 prints on the bed, and only one of them failed in this way. You can see it detached from the base, and it actually recovered surprisingly well. But for the sake of stuff like this, I've been doing more and more on the work printer, but that's fine. Everyone knows about it, and other stuff, people print stuff there too. It's great. It's all going great. Where were we? Power and data connector, right? So if you see on the bottom here, spin this around. So I've labeled the nets that these are connected to. So we have a ground and a V+ pin. So we have DC power there between 12 and 24 volts, and that limitation is because I'm nominally between 10 and 24 volts. The forward voltage on these LED stars is 10 and a half, 11-ish volts, and the LED driver that I'm using, you have to provide at least the forward voltage of your LED for it to work. So I just say, put 12 volts into the thing. The converter that we'll solder on in a second here, that provides a source of 5 volts of power from the DC input. So it's going to take your 12 to 24 volts and step it down to 5 volts to drive the microprocessor and the RS485 converter and the servo motors, the things I'm using here have a maximum voltage of 24 volts. So need at least 12 volts for the LED, can't go above 24 volts for the converter. I think it's actually like 28 volts, but like, let's say nominally 12 to 24. So both of those get put into a single connector there. Let's solder on more connectors, and I'll talk more about them. So the pan and tilt servos get a really standard 3-pin servo header. And that's, 5 volts ground and a servo control signal. So I will solder those in next. I have to say, those who are often here on Sunday nights knows the last 6 or 7 sessions that I've been here for Sunday nights, I've been here on Sunday nights for, have been Raspberry Pi based, and that means I need a kind of a different monitor setup, because I need a monitor to basically have the streaming setup on. I need a monitor for the Raspberry Pi, and then I use a monitor to like show slides and stuff. And I've reverted back to my older setup that I used to use when we were talking about Arduinos for this, which puts the streaming information like front and center in front of me instead of kind of off to the side. And it's both really great because I can finally sort of see in better detail what's going on, and it's really throwing me off that like my face is now looming in the center. I mean, that's where it was for all of, proper quarantine, but it's still kind of weirding me out. Let's see here. So all I'm doing here, just to talk about it as I do it, is I ordered a bunch of these little 3-pin headers from LCSC, which is the part supplier that's associated with GLC PCB, and you can see they're sort of centered in the plastic there, and I really want that to be more offset, like this first one I did here, so they get as much sort of contact area as possible to plug the servo header into. I'm having a bit of trouble with this one. So all I'm doing is basically pressing the plastic down on... Oh yeah. Sorry, my wife just very spookily poked her head into the office. You can say hi. This is my wife. She's not a ghost. Although she did plant some Halloween decor in the background here. I don't know if you can see just above the Build Test Repeat sign. There's a little scarecrow there.
I told him he should put it in a more accessible location. But...
I have a blue tack. We could just stick. Does he have a name? Does she have a name?
I don't know.
All right, think of names.
Your audience will tell you.
Amazing. Yeah, Nate, Chris, and Palmer, say hello. Hi. Yes, come. No, come in anytime. It's casual.
I said it was your off week. It's cash.
It's cash. It's totally cash. It's so casual. Josh McCammon says hello, by the way.
Oh no.
Wow, Josh, I don't know if you heard that, but if you didn't,
Josh.
it was fine.
It was
Oh no, I've discovered our first error. Well, not our first error of the evening.
All right, back to your drama.
Yeah.
Bye, everyone.
Bye, Mary. You know what would be really great is if when things go wrong, like really, like if this was a green arrow pointing up, and then when things go wrong, it's spun around to be a red arrow facing down. Okay, so here's what I've noticed. So these positions here, let me get the glare off them a little bit, are where the servo motors are meant to plug into. Did I pull servo motors? I thought I had. If not, I have a bucket of 60 of them. Oh, here, there we go. Couldn't hear my sweet tunes. Let me, as always, know if there's audio issues, if the music's too loud or too quiet, all those things. It's just there for fun. So, hobby servos, we'll talk about in a little bit there. You want that header? Oh, yeah, want the header fixed. Yeah, well, it's a prototype. It's all fine. So on these little hobby servo motors, like many little servos, those of you who were around for the servo motor control stream back in April, which feels like about 100 years ago, will remember your servos take 3 wires, power, ground, and data, and they plug into a little standard 0.1-inch header that you mount on your project somewhere. So that's what I was about to solder on, except that apparently, and this is just like one of the joys of doing it live, look at the spacing on these headers that I bought. They're not right. Maybe they're 200 millimeter headers instead of 200, or what would it be? 2 millimeter headers instead of 2.54 millimeter headers. Woof. Well, thankfully, this is not irrecoverable because I have a whole box of headers. So we'll just use some of these, and I will make a note to order some new ones. Part of the joy of ordering from LCSC is if you're ordering circuit boards from JLC PCB, you can combine shipping between the two. At least you used to be able to. Nowadays, I think for like import tax reasons, they don't let you, but when you check out, they give you or at least when I ordered these maybe a month ago, they gave me a coupon equal to the amount of shipping for the second order, but they did ship in 2 separate boxes. So I don't know what the story is there. But like their note on their website like implied that it was for like, we can't do this for tax or export reasons or something weird. Wow, Chris, Electronics Bash 3 motors and servos April 5th. April 5th. I feel like I was a different person back then. For better, for worse. So let me solder on these servos. So these, you can see these headers are quite a bit larger, and they're already sort of with that plastic offset. So I'm going to put the shorter end down into the pan and tilt servo headers here. Chris says we were all younger then. Yeah, cool. Thanks. Good joke. Good jokes all the way around. And you can see I like to use a little bit of blue tape just to hold the headers temporarily in place. And then I really like this PCB vise. I wasn't a PCB vise guy. And then my dad got me this, I think, for my birthday last year. And it's really super convenient. The ability to like flip it end over end like that, so you're working on the top, you're working on the bottom, is like really, really nice. So this time, just to like help everyone with OCD out there, I'm just gonna solder one tab at a time, and I'm gonna flip it over, I'm gonna check alignment, and then I'm gonna finish soldering them down. You'll notice, by the way, that these headers are not adjacent to each other, they're slightly spread. This is a known fact. Hey, Dave Miser. I feel like there's a person back there. Yeah, we were all humans instead of just survivors muddling our way through. So these servo motors are meant to plug into 0.1 inch headers, but if you stack too many of them up next to each other, you start to run into issues with the width of the housings. So like, the rule of thumb is you can only really put 4 servos next to each other on real 0.1 inch centers before you start to run out of room. I've just gone ahead and put a little bit of space between them just for good measure. Let's check that alignment there. That's not awful. I'll show you. They're a little bit tilty. So I'm gonna see if I can adjust this without burning myself. There we go, and just settle that right in there. Settle that right in there, and no major burns. Oh, this one's a little bit waddy compass. There we go. Whew. So, yeah, there we go. If you do a lot of electronics work at home, like, it's a good reason to keep your fingernails long, which I don't typically. They're typically longer than this. Keratin's a pretty good insulator, and so for holding things like hot components and hot wire, I just end up using my fingernails a lot. I don't know if that's common. That might just be a thing that I do. So there's our pan and tilt headers there. Let's do the programming header. So this will be a fun thing. We'll come back to this in a little bit. So for those of you who remember the old version of the Demilight, which is this one of? Yeah, Let me zoom out, and this will make more sense with a little bit of context here. Let me pull the lid off of this. You'll see that this older version of the circuit board has 2 rows of headers down the side there. That was actually a socket for an Arduino Pro Mini. That was the brains of this thing. You'd socket a Mini in there, and then this hole on the side was so you could plug in your programming dongle without taking the thing apart. So one of the nice things about that, it was really easy to... looks like the MOSFET did some burning there. Did I do some burning? Oh, yeah, for sure. So this is one of the, yeah, we'll get to power distribution in a second there, but we've gone to a much less burny power solution here. One of the things that was nice about that, our sort of like snap and play Arduino setup, was it was really easy to reprogram. And now that I have the processor right on the board here, I need a way to program it once it's in place. So what I've done is just drop in a little footprint for a 6-pin, it's called an ISP header. Chris, you want to pull what what episode of Electronics Bash we talked about taking your Arduino off of the Arduino board and talked about ISP headers. I'm gonna guess it was 14. That's probably not right. So like before, I'm gonna just do one. This really should be a 6-pin header. And if I ever make a kit of these, when I make a kit of these, it'll be just one 6-pin header to solder in. For now, because of course I goofed that up, I'm going to use 2 3-pin headers, and to make sure that they're aligned right, I'm actually going to use the thing that 11 says Chris was the talking about taking the chip off the Arduino board. It was so close. To make sure these are aligned right, I'm going to use the thing that it's going to plug into them. This is an ISP cable that will plug into our programming unit to allow us to program these later on. So what I will do is just slip that over the end there and make sure it fits. And yeah, that's actually being good contact. I've done some of these as prototypes that like they end up being like, wah, and you can't plug the thing in. But since that seems to be fine, I'm just gonna flip this over, and we'll finish soldering the rest of the header here. An ISP header is a pretty standardized part. I mean, once you get into more advanced microcontrollers, which I don't typically, but they have various other ways that you're meant to program. You know, you order your boards with the controller on them. How do you get your code onto them so you can actually run your code? There's various ways. ISP headers, one-wire programming headers are kind of popular in like ARM-based development, I think. There's a really cool project that I should plug. Not my project, called the Amazing $1 Microcontroller, where if you're interested in microelectronics, that's a really cool place to be. It's by an enthusiast who basically went and found 10 different microcontrollers that you could order for $1, and goes through the process of like, okay, it's $1. How cool is that? What can it do? What do you get for the price? What's the tool chain like? Like, what software is the vendor providing to make it functional? What are the gotchas? How much power does it draw? Super cool project, both if you're like interested in cheap microcontrollers, but also just a really great way to be like, what are the parameters of a microcontroller? Like, what attributes of it should I or would I care about? Really cool place to start. Same author just this past week released, and I wish I could remember the person's name, released a similar coverage for building out embedded Linux systems on inexpensive single board computer type things. Like if you're building your product currently with a Raspberry Pi and you wanted to like turn it into an embedded Linux system, what chips might you use? Super cool. $1 microcontroller, definitely relevant to all the nerds here, I suspect. Okay, so that's our power and data header. That's our pan and tilt servo header. That's our programming header. There's one more through pull part that we need to put on, and it is the power converter here. And this is the part that I referenced earlier. That was the first error that I noticed, but this is now the second error that we'll encounter. I'll show you this one I prepared earlier. So this is, it doesn't have the other headers on it, but this is the power converter we're going to be using. They're very cheap units from China. You can see on some of my earlier prototypes, we have these nice plastic encapsulated units, and both of these are buck converter modules, right? So they are taking in anywhere from, say, I think 7 to 24 volts and bucking it down here, 7 to 28 volts, and bucking it down to 5 volts up to a certain amount of amperage. And the nice thing about using a buck converter, which is an architecture that basically just sips off the higher voltage rail any amount of voltage it needs to create those 5 volts in a capacitor at the time that it needs it. That's kind of a hand-wavy definition, but rather than burning off the extra voltage like a linear regulator would do, where you're wasting all the sort of excess voltage as heat, which leads you to situations like Chris spotted where you have a lot of heat build up inside of your unit, these are much more efficient, and so you get a lot less heat waste. This module that I was using was like a couple dollars, maybe $2.50 in the quantities I was buying. These are like 60 cents a piece, and they're perfectly fine. They're just not encapsulated, and they're a little bit bigger, which leads me to the problem I encountered. I didn't change this base when I made that part change, and if you stand, it'd be a little bit hard to see down in here, but once the circuit board goes down in, if the converter was standing straight up, it would be in the path of where that lid is supposed to go. So for the time being, I'm going to probably have to have these guys doing a little bit of a lean back, which is going to mean they're going to kind of get into the way of the servo headers here, which I just realized. So that's less than ideal. So the real thing that I've learned is I should make this box just, you know, like 3 millimeters taller. But for the sake of this evening, I think we can make this work. Let me see. So that would mount down there like that. So I guess I could lean the other way. It could lean forward some. It does have to be in this orientation because on the modules themselves, they have to be, you know, in, ground, out, right? In, ground, out down that way. So I can't, like, flip it 180 degrees. Let's play with this a little bit. Palmer asks, I wonder if that vise would work for audio connectors. How close together can you bring the jaws? Rotation seems convenient. Yeah, Palmer, I love this vise. So the functionality of it, and we'll just take a little diversion here because that's what we're here for. You have this central bar down the middle here. Each of these assemblies is affixed with a set screw. So if I loosen this one set screw, I can slide that one along the rail. If I loosen this one set screw, I can slide it along the center rail. I'd just like to keep one sort of flush to one end, so it's sort of less in my way. And then I slide this one as far or as close as I want to. Yeah, it's a sweet vise. So you really get as close as far as you want. And then once you've locked that down, Josh, this is for you specifically. I will make them kiss. So you can do that. And actually what's cool is one of the jaws is of course spring loaded, right? So what I use it for at least is I, you know, take my circuit board, I set the jaws, I actually usually do this with this in place, I set the jaws to be just touching the thing, then I slide that base in a little bit to compress that spring, lock the lower thumb screw, and now I have this spring putting just a little bit of pressure on the board to hold it in place, but I can pop it out just by compressing that spring myself, and the board pops right out. So yeah, super cool. I probably put a link to this somewhere someday. Oh, you know where it is? On my... I did a blog post last year. Actually, I should refresh it for this fall on like all the tools I would buy if I were building out a new workbench, which is on my blog. Hey, plug jeff.glass/blog. And yeah, it's I'm sure this is on there, and if it's not, it really should be. I think it's from Amazon. It's not a terribly fancy product, but it's really useful. Yeah, the spring-loaded feature is great. So where was I? Oh, I was gonna look at whether I was going to have interference between my servos and my power here. So what I'll do is I'll plug in a servo header there. It's also really nice if you're like, I don't know, building things while you're streaming them, because you can be like, where is their glare? And then just make it go away. Let's see. Let me grab another. I had a bag of 50 of these power converters, which was like $20. It took like a month to get here, but very inexpensive. As with anything, right? You know, good, fast, cheap, pick two. And often I feel like for us hobbyists, we pick cheap and good, and you give up on the fast. And so if you're willing to wait, 6 weeks for shipping, you can get some really neat stuff for almost nothing. So that looks like about as much as I can comfortably lean that back. Let me find, where did I put that other board? Here we go. Let me compare. So it looks like on this one I prepared earlier, it is leaning back just a little bit further than that, which is a little concerning. Maybe what I will do, and sorry for those who this will offend, I'm going to lean this servo header back some. Oh, I hadn't finished soldering these. Good, that'll make this easier. I'm going to lean these servo headers at an angle as well, just to give ourselves a little bit more room to play. Let me tighten this up again here. Let's see. Been to a theater lately? I have not been to a theater lately, no. I wish. Let's see. Jeff, tell you with a cable you can put that power converter anywhere. So Palmer, I'm not sure if you're joking or not, but I'm the one on the camera, so I can decide whether you are or not. So one of the reasons that we want to, bring in a high voltage to the unit rather than putting, a 5-volt converter, say at like the head end or a separated power supply or something, is your voltage drop in the cable that's feeding these things would be fairly... Oh, I leaned them the wrong way. They're leaning, can you see? They're leaning toward the converter. That's what I get for trying to make fun of Palmer and solder at the same time. Let's try this again. So I want the voltage coming in, coming across the wires to sort of be as high as it can be, and then I'll step it down locally at the unit just for the little bit of 5 volts that I need locally. Ooh, that's hot. Well, of course, because it's solder. So if it were me building out a system of these, I would, run them at 24 volts, and instead of 12, although you could do either. And that would sort of give you the least voltage loss in your wires. Try this again here. All right, I think that'll stay. It's a little bit PF janky, as it were. Palmer says you could botch in 3 short cables and rest the converter. Oh, that's true. I could I could wire this up somehow that it would be here, I think you're saying, Palmer, or somewhere stuffed in. Yeah, that's not an awful idea. If this fails and doesn't fit, which we'll find out in just a second here, then I think that's a really strong option. So that's kind of as far mechanically as this can lean. Let's see if that, let me get that back on camera there. If this will still plug in. Yeah, I think that's okay. The movement's not being impeded by the servo header anymore, which is good. Going to fix the input header? Chris, let's not get crazy now. If I didn't give people something to be worried about, then what fun would we be having? All right, let me solder this power converter in, and then we'll put it in the box for a second and see how hosed we are. So again, a bit of blue tape. Let me just double check the orientation on this. So you can see it has a little an in marker there, and I can see the power trace here coming from, is that as zoomed in as we go? Now there we go. So you can see, if I point to it with the screwdriver, so this is my V-in pad. It goes in through a diode, so we have reverse polarity protection, right? So if you plug your cable in backward or sort of upside down, can't fry anything because this diode's protecting us. And that trace comes over here to the input pad here. So that is going to be my input side. Just tape that in place. That's a bit how you doing. Ooh, I also need to finish soldering those servo headers. Well, that's good. I can do that while we're right here. So we'll just tack those in. One of the challenges of doing all the rework on these boards. So I typically keep a chisel tip on my soldering iron, which is a really a flat bladed tip for through hole work. But I have a much smaller pointed tip, a pencil tip for surface mount work, and having to switch back and forth between the two of those while the iron was hot or is hot is always kind of a dicey adventure. It's why in my workshop at work I have 2 soldering irons. It's not why. I inherited a second soldering iron at work, and I have one of them that's loaded with a chisel tip and one of them that's loaded with a very fine tip. So if I'm doing both, I can leave both irons on. I don't have to switch tips in one iron in between things. So, other thing I discovered earlier is I need to trim these leads off pretty flush on the power converter there for this to fit. Okay, well there's that looks great, doesn't it? Doesn't that look? It's a little bit exciting. Ooh, yes, good clarification, Chris. Yes, use proper ventilation when soldering. I should also, just let's be good. I should wear eye protection. That's a real one. I've told this story on stream before, but I did once have a piece of solder come up and hit me right here under the eye. That was a scary and exciting experience. I guess I put them on now that I'm basically done soldering, but just, someone take a screenshot of that and you can send it to my parents and they can be happy that I've done the thing. Move this vise out of the way here and zoom out just a little bit. So one of the things I did in version 0.9 was reformulate how these circuit boards attach to the board. Previously, I had been using, let me see if I really should have gotten out more of the older boards to show off, but thankfully, they're in this bin. So here's a version, what are you? Version 0.8.1, that's pretty recent. So I had been going with 3 little M2 screws. 1, 2, 3. These holes in the corner are actually byproducts of the PCB manufacturing process, so I didn't put them there. But 1, 2, 3 M2 size screws, which are really tiny and kludgy, and those would go into heat set threaded inserts in the 3D prints, and that just wasn't a great system. So what I've gone to now is just one M3 not machine screw, sheet metal screw that goes down into the single hole on the board here, and that sits right behind the place where the connector cable goes, just because I figured that's, as from an end user perspective, is the place where there's going to be the most like mechanical strain. The problem that I'm running into though is that my the sheet metal screws I was planning to use haven't arrived yet. That was another one of those like, oh, I'll order it slow. I need 100 of them. They're not fancy. It'll cost me $1 and they'll be here in a month, and they're still not here. So for tonight, we might do something a little bit PF janky and just stick that down in there when the time comes. But the thing we wanted to learn here was, is that enough clearance for the lid to slide in? And it's going to be really close. I think if I file this back a little bit, which I do need to, I think we're going to make it work. So if I file it back, I mean, so you can see under the sort of lip there's kind of an undercut. And it's deliberately small and tight because I, of course, really want this to be a tight fit so that the lid doesn't, slide out on you. So I figure like when I release the files and guide for this ultimately, I imagine there will be some details like this that will say things like, hey, this tolerance is deliberately really tight. If your printer is really good, it might fit perfectly, but you're probably going to need to file a little bit of it back. And again, that's because I feel like a too tight tolerance that you can file back is preferred to a too loose tolerance that how are you going to fix that, other than with like glue or something. So let's see if that's enough. What is the orientation for this? Must be like this. It's going to be a little tight still. I also probably could do a better job of cleaning up these edges. So on my home printer here, I have to print everything with a brim, which is an extra bit of plastic all the way around the bottom, just to help with adhesion, because the bed on my printer is not great at holding on to things. So on the nice printer at work, that is not an issue, but it does leave a lot of this like little flashing around the edge, so I'm probably gonna need to file that back a little bit here. Let's see. Ooh, Palmer, your TS80 was delivered. TS80, is that right? That's the USB-C powered soldering iron, right? I've not played with one of those. I really want to know what you think of it. 'Cause just as like a, I have this dream. So at work, I have a butane powered soldering iron for portable things. But I love the idea of like walking up to something that's having an issue with my, USB-C 80-watt iron and a little portable battery bank. And being able to solve problems that way is super attractive if those things work as well as they claim to. So Palmer, when you've given it a shot, I'd love to hear about it, because there's some real potential there. Chris asked what layer size are these printed at. So these are all, I think, printed at 0.2 millimeter layers. These boxes might be 0.25 millimeters. Really, there's nothing. I guess the tolerancing would be important on this interface right here. But when we're talking about 0.2 versus 0.15 millimeters, I think the tolerances are squishier than that even. Stuff like the body would probably look smoother with a smaller layer size, but I don't think, and it's a very good point, that layer height's going to make a huge difference for some sort of standard layer heights. Yeah, so this is still really tight, but I actually don't hate that. Well, maybe we'll file that down a little bit more in a second here. So I think what we're going to do for the lack of screws here is just hold... Oh, man. There we go. I'm just going to hold that circuit board in here with a little bit of blue tack here. Hang on 1 second. I swear I'm not just grabbing things because I want to show off the animations, although I am having a delightful time learning how to do animations in OBS there. I am just up above camera level here, so you'd be looking sort of very intimately at my shirt if the cameras were still on, grabbing some blue tack, which I think is going to be a really nice tool. It's in the glues and adhesives bin. There we go. We're back. Thank you for waiting. Please hold for tummy cam. Yeah, something like that. So people who have been here before know I'm sitting at my workbench. All behind the camera here on that side is like all of my, well, a lot of my various storage. And so if I need to go up there and get something, I get real intimate with these cameras at that point. So I'm just going to use a little bit of this blue tack here and stick it down in the place where that screw would be. Try and get it nice and flat so we're not adding unnecessary height, because we're going to need all the height we can get. We'll stick that in there. And then, oh, it's going to be tight. All right, let's see if this goes in. So actually, maybe I'm going to delay the inevitable a little bit longer to do a little more filing, because the filing's going quite well. Oh, yes, ab cam, right? At some point, we decided that it was not going to be tummy cam anymore. It's going to be ab cam. I don't love that term just because it really shows off just how swole I am, and I don't like to rub that in people's faces. All right, let's see here. So that's going to slide in like that. Blue tack as the white version. Yeah, I guess I don't know what else to call it. What does it call it? Poster putty. The generic version is poster putty. But I have always thought of it as blue tack. All right, go in there. Oh, it's gonna. Oh, well, that's a part that needs reinforcing. I've just snapped that there. Thankfully, I have 9 more of these, and we're not finishing 10 of these tonight. We'll be lucky if we finish a couple of these tonight. Ooh, it's gonna be real close though. Ooh, it's gonna be real close though. All right, I think this will work about once, and maybe not more than once. Like it fits, but it's rubbing. So I think maybe let's call that a qualified success, and we will cram that in there when the time comes and no sooner. And see, I was applying too much force and I snapped that off. One thing, so this is actually the servo holder part here is like the oldest part on this design. Like this was actually where this project started, is I was designing a part very much like this to hold a hobby servo for another project. And I was like, oh, that's kind of interesting. But something I would certainly do now, and I should do, is chamfer or all of these interface edges, because a place where 2 3D printed parts meet at a right angle is a weak point. Because you can see, if we look down at what snapped there, how little plastic is actually holding those two things together. And by chamfering those edges, rounding them off internally, you build up sort of a gusset where there's additional plastic of reinforcement at the joint. That's a really good practice to get into if there's not mechanical concerns. I couldn't do that on the inside because the clearance to the servo is so tight. Like when that's in there, that's a really tight interface. But I certainly should do it all over the outside, and then I could probably account for that in the aesthetic cover. So a little thought for y'all there. Well, that's broken. Thankfully, I have a bunch more. Let's see. Sticky tack, says Nate. Yeah, I would buy sticky tack. Let's see. Blue Tack Palmer says, if you ordered a product, and when it was delivered, you saw that it was 3D printed, would you wish that had been made clear in buying it, or would you be okay because the technology is fine as is? Woof, what a good question. I'm interested to hear what folks in the chat are thinking as well. I feel like it really depends on what the product is. And frankly, like what the vendor is. Like, if I'm buying something from, like, a big company and a thing comes 3D printed, I think I'd be a little bit... I think 3D printing is not a technology that scales super great to large volume manufacturing. And so if I got a product in that was 3D printed, I think what it would communicate to me is, oh, this is a low volume product, for some value of low volume. But that might be okay. So there's a really cool maker who I follow on Twitter called Lixie Labs, who makes these cool devices called Lixie and Pixies, which are sort of like 8 by 12 LED display modules that you can do fun things with. And he sells them with, I know he calls this out in his post, with a 3D printed enclosure for the sort of main module if you want it. And I think that's the perfect case for a 3D printed thing, because he's doing them in batches of, 50 or 100 of these modules, and I don't know how many people buy them with the enclosure. But I feel like that's kind of the ideal scenario where like I have this low volume thing, it's a super custom shape, it's a weird interface. Here's a 3D printed case for it. I think it's really cool. Prusa's parts are 3D printed. Yeah, so the Prusa Mini and the Mark II and Mark III, all of the non-metal parts are 3D printed in PETG, and they look great. I mean, but that, to be fair, that is a 3D printer. So, like, there is that, you're targeting the right market there for sure. Polarity question was a clamp to hold an intercom, belt pack, and headset to a table. Ooh, I feel like in that case, and happy to be disagreed with, I feel like that's a product that I'm wanting so much mechanical stability out of that I would be sketched out if it came 3D printed, even in a really nice material. But that's just me. Like, I want that part, I want that clip to be metal. In fact, I feel like the headset, like the ComBox clamps that I have seen are metal. Yeah, weird. Let's see, let's mount some servo motors, shall we? So there's one set of screws. Here's the other set of screws. So like I say, so I've swapped out the broken lid piece there for a whole lid piece here, which is great. I'm gonna mount the Pan Servo to this guy, and this will be nice. I'm fairly confident this will work because this design really, as I say, hasn't changed much in the last 3 or 4 iterations, and so I'm sure this works pretty well. So all of these hobby servos, at least all the ones that I've ever bought, come with a little assortment of like horns, they call these arms, that snap onto the top of the servo here. Horn is the technical term. And then they come with 2 larger screws for mounting the servo to whatever you're mounting it to, and then a smaller screw for securing the horn in place, which we'll use to mount the yoke in a little bit. So I'm just gonna come in with my 2 smaller screws here. Be a little tricky to do this in a way that it's not blocked from the camera, but I feel like y'all have seen a screw going into plastic before. We'll do that. We won't quite tap that all the way in. And we will do the other side. Palmer says, not sure he would have bought that 3D printed mount if he'd known it was 3D printed. Maybe that's what, yeah, that's for a mechanical part, you know, we're like, hey, this is an accessory to an expensive thing you already have that you're going to rely on it to not drop this, you know, several $100 thing to the floor. I would want to know, I feel like. And let me be clear, there's nothing wrong with a 3D printed product, especially if you're doing this, especially if you're in, I feel like, the hobbyist market or the low volume market. Like, that's really the only, you know, if you're not going to have somebody mill out a professional injection molding jig and make you 10,000 of the thing, like, maybe 3D printing is the only economical way to get your thing made, and I think that's great. But I feel like you should be upfront about it. So there's this is one unsolved question in version 0.9, is how to hold the aesthetic cover, the Pan Servo cover, on. Now, why did I... So here's interesting. I put a little notched edge there. Did I mean to, or is that an artifact of the drafting process? When we get later in assembly, I'll show you the drafting, because I was, you know, I want to cover sort of all the bases of this project as we go. But for now, that's just going to kind of sit on there, which is not ideal. Maybe some more blue tack is the answer. Let's just squish that on there. Perfect. Yeah, so some solution there. Maybe it's an additional screw or clip or something, but that feels like a solvable problem. All right, so that's on there. Let us mount the servo inside of the body. So this is the tilt servo. So in our completed version here, that's the servo that I'm moving when I'm turning this interface. Right? And that just mounts down on those 2 little points in there. It actually only goes in with 1 screw, but that's been plenty to handle the pretty negligible forces that are on it. Oh, here we go. I'm just looking for my other bag of servo hardware here. So what I end up with, because I don't use these little plastic horns for anything, I end up with like piles and piles of them and none of the little screws, which I'm always losing. So not ideal. So if you have a project that needs 100 little tiny servo horns, let me know, and I'll send you mine. Let's see here. So this is just going to take 1 screw right down into the body there. Screw that in. And that's so those do have a little hole in the 3D printed part, just as a starter hole. But as I'm screwing these in, the threads of that screw are actually biting into the plastic a little bit, just to make a nice strong interface. So there's not 3D printed threads in there, is what I'm saying. And then this, oh, I should have done this beforehand, is threadable through the rear part of this body. Ooh, yeah, that's a real pain to do after you've already installed the servo. If and when I ever, like write assembly instructions, this would be a thing to point out, is like order of operations. Oh, interesting. Wonder if this is one of my older bodies, because the servo header is actually not... Ooh, it does fit through. I just need a better angle. All right, I'm going to unscrew the servo, and I will thread this through, thread the connector through, and then I will thread the wires for the LED through, which are also a pain once you've installed the servo. See, after 9.5 versions of this thing, we're learning. There we go. So I probably just need to make this hole even a little bit bigger. I've been trying to keep it small for aesthetics, but this is just untenable. Actually, I guess now, so part of the reason I was keeping this little like solid tabby do here was for strength, but that was before I had the like web of tabs between the two halves of the body, so that might be redundant. I might be able to just cut this whole thing away. Cut the connector off, says Chris. Oh, there we go. See, it fits perfectly and easily. So now I'm going to thread the wires. So this is something I prepared earlier, is all the wires on these LED stars. I'm going to thread these through that hole there as well. Now I can mount the servo in place. And that goes this way. Let's see. Wish I'd known. Yeah, is it ABS? Is it PLA? Like, yeah, it's interesting, right? Because in any other manufacturing setting, I guess the takeaway there, Palmer, is I'm getting the sense you don't think that it's unclear because it's 3D printed whether it's actually strong enough to do the job. And I feel like that's a concern that's not necessarily unique to 3D printing, right? If you were like, it's a com clip holder and it showed up and it was made of vellum, right? Or if it was made of such thin aluminum that it wasn't, you were questioning whether it could do the job, it would be the same issue. And the unique thing about your case is like just the fact that it's 3D printed kind of gives away that it might be that to begin with. All right, so servo assembled, LED star pre-threaded through, super critical. Let's assemble. So the other half of the body is honestly just aesthetic. Like this just snaps in there, but it doesn't serve any mechanical function. It just looks much better this way. So I'll leave this off for now. We can slam that in right at the end. There is room in here for a small heat sink, and that's deliberate. But for now, I'm not going to put one in. And we'll see how we do. You can see there's these little ventilation holes in the top and bottom here. I have not had one of these do any serious melting on me yet. But maybe if we get to testing this later tonight, we'll learn something. So the yoke here, right, is obviously oriented so that this taller part of the yoke should, and this will be, so these are the first yokes I've printed on the Prusa, and I think the tolerancing, again, is just a little bit tight, which I don't hate, but it's a good thing to know. So I'm just going to take a little rat tail file. I should probably put this other file back in while I'm thinking of it. Get a little rat tail file, and we'll just run this around the inside of the unit there just a few times. That'll just loosen that up, because the idea is that's meant to be a press fit onto that servo nodule. It's interesting, on my Maker Select, this is actually a much looser tolerance, and on the Prusa it seems like things are just a little bit tighter. So let's see here. But you do want it to still be a tight fit, because the thing that keeps the part from spinning on the servo attachment point itself is actually friction with the inside of whatever it's mounted to. Do you need to zero the servo? Yes, Chris, I do. I will do that probably when we get it powered up. I guess I could do that with one of these horns. That was exciting. Yeah, kind of a tight fit here, which is interesting. Wonder if there would be a way, like if there's a standard size drill bit that's close enough to this dimension that I could say like, hey, you know, if you're building this, file this away or gently drill it out to, you know, X of an inch or whatever. Let's see, you know what, we could have an easier time testing the fit with this unit just because it's a little bit more exposed. Ah, there we go. So yeah, so that does fit. It's very tight, but I think that'll work out. So, oh, yeah, just a little bit awkward in there, but I think that'll be okay. And then I'm going to use the smaller of the screws that came with the servo to hold that in place. This is, I will admit, one of the parts that would be most nervous about putting in the kit, because if you, well, I guess not if people are 3D printing their own parts. Because if you overfile that point, you would, you know, you'd lose connectivity. I don't know if you can hear, but that's the servo moving. Ooh, and there it is. That clicking should not happen. Like, we should have a stronger friction interface there. Yeah, I think I might even need to do just a little bit more filing on this guy. That's what y'all tuned in for, right? Was filing, YouTube filing stream. Ooh, yeah, it's really tight in there. Chris says he made, oh yes, so that's a very common thing I've seen, Chris, is like, not very common, but a clever thing I've seen is rather than trying to like make your own interface to the servo, you make something that basically surrounds this because these are manufactured to fit correctly on the servo. Nate says, would a washer under the screw head help? Maybe. Really the issue is, so the way that you're meant to attach to these hobby servos is, I don't know if you can zoom back in here. Zoop. Sorry for the, you can see that this servo head maybe is just very slightly toothed. And you're meant to have something that really, there, you can see it there, that really precisely interfaces with that toothing. And this is a little bit pliable, so you can compress it a little bit. But you really have to have a pretty good tolerance to part to interface with them, which is a flaw if you are trying to do your own small manufacturing, frankly, which is what this is. There we go. That's better. The other thing is like there's very, very little mechanical force being put on that servo joint. So like even if it's not perfectly mechanically sound, once this is off and running, it's not like it actually needs to really exert too much force, so I think that will be okay. I probably should have filed this one before I attached that one, but that's all right. We'll go ahead and we'll put the servo cover back on here. And then this, of course, is going to need, I assume, although I was going to say I assume this needs the same amount of filing, but frankly, these are printed in two different orientations. So let's test fit it before we get too far. This one I think is closer because it is printed. Is that true? No, these are both printed as horizontal holes. Dave says a lock washer or split washer might help. It would certainly help hold the screw in orientation to the 3D printed. So I guess let me just make sure I know what we're talking about here. So it'd be like screw, lock washer, 3D printed part into the servo, yeah. So the screw wouldn't rotate against the part. Oh, that's interesting. Yeah, that may help. Really, the issue is that the part is spinning against the plastic bearing of the servo itself. And I don't know, even if you had the screw locked to that, you might still be able to spin there. Oh, Dave says between servo and arm. And that's an interesting idea. I wonder between the servo. So here's the trick there. Let me see if I can get you close enough to see. And maybe we should still try this. When that servo is fully in place, it's the 3D printed part will fully surround the part. And so I'm not sure, and this surface here won't be flush to that servo surface. So I'm not quite sure within that where a lock washer goes, because we want to be locking this white plasticky bit to this bit, right? Or maybe I'm still not quite understanding. But if there is a solution that involves like a lock washer, I am all for it, because clearly this is a little bit kludgier than it needs to be, right? There is also the world, as Chris says, where we go to like something that encompasses one of the pre-manufactured horns. But I'd rather keep it as 3D printed as possible if I can. Ooh, here's another order of operations thing. It's going to be hard to get to that screw with this gosh darn servo in place. So what am I going to do here? I can't undo that servo. I'll have to redo all that work. Let's see if I can get in at it anyway. But yeah, maybe, did that track, did that final logic track? Or disconnect the arm? Yeah, I could disconnect the arm, Chris, but I just got it attached. There we go. Get in there. It's going fine. It's all going great. Oh, no, it's not. No, it's not going great at all. Yeah, I'll disconnect the arm. It'll be fine. I need a 90-degree screwdriver with little tiny... Did they make... So I love my 90-degree screwdriver. I've got it right here. But I've only ever seen them, I think, with these, like, you know, chonkier bits. And I know you can get, you know, precision screwdriver bits in this form factor. Does anyone make a right-angled screwdriver where the like where they're meant to be a jeweler's screwdriver size bit? Does that make sense? Like not a full size, you know, number 2 Phillips bit size attachment, but like a jeweler's right angle screwdriver. That's what I want. Yeah, make sure you... this is what's embarrassing is, well, what's true is, like, I feel like I have done this exact series of errors for most of the times that I've disassembled these. I think it was Nate who pointed out that, like, on my streams, I really need a to-do list of, like, what I have to do before each stream, including, like, turning all the lights on, making the mouse pointer the right pointer, and I was like, oh, that seems like a useful idea, and then I did it, and it was really helpful. Similarly, a list of instructions would be super duper helpful here. Becca Jeffords, hi, how are you? It's so cool. Thank you for joining us and a group of wonderful nerds this evening as we build little tiny moving lights. Let's see. All right, so finally that's assembled. So that's actually fairly good. And like I say, this is just aesthetic, right? And that is, oh yes, I did thread the LED wires through at the right time, right? So those will pop out of here. So the LED sits there, wires go underneath the servo there, and other half of the body clips on here. Great. Yeah, so that's 4 of the 5 pieces assembled, so it's just now the base, which is a great place to be. So before we install that, let us go ahead and get it programmed. And I'll talk a little about how we program these little tiny boards as I get that set up. So as I think I mentioned earlier, let's see, Dave and I are happy to catch a stream, watching the vids later. Aren't these adorable? Aren't these super, super cute? I feel like, I don't know where you put googly eyes on one of these, but I feel like there's some strong possibilities there. So as an ATmega programmer, I use this old tiny ISP programmer that I bought from Adafruit like in 2012, I want to say. And it works really well. It just works. So I'm going to plug that into my USB-A cable here. We can see it connected because it had that green LED hook up, and it connects to the Arduino IDE. So I'm still programming all of these in the Arduino environment, which is where I started with them, and frankly, it does more than enough for my purposes. Just for interest's sake, for those of nerds out there who are interested in Arduino things, here's a quick rundown of how this code is working. It's really very simple. So this is the code that'll be flashed to the moving light itself. There'll be a separate bit of code that we'll be using to make a little controller for it in just a little bit. So we're including the Servo library and the Conceptinetics DMX library. Conceptinetics is a little company that made DMX shields for a while. I think they still do. Their DMX library is the best that I have found out there in the world, so I tend to use it, at least for basic functionality. They have some code related to RDM, to remote device management, which is not terribly fleshed out, that I've actually been putting in a little bit of work on. But I'm just like a basic DMX sending device or DMX receiving device, a great bit of code to use. I define where my various things are attached. So my My LED is not, of course, directly hooked to pin 3, but if we look at the circuit board here, this chip, this little tiny 8-pin chip there, that is the LED driver pin, and it is interfacing with what would be pin 3 on the Arduino if this were a full Arduino board. So rather than doing pulse width modulation directly out of the board and into the LED, it's actually being used to control an intermediate driver chip, just so we can push a lot of power out of it. We also, there we go. So we have our pan and tilt servo hooked up to pins 5 and 6. We initialize our library and we set our DMX address here. This is another thing that I'm currently working on in a couple different ways. Like, how do you set the address of one of these little tiny lights that doesn't have any real physical interface on it? And there's a couple of different ways that I'm trying. You can look at my face because I'm looking at, I don't know if you can see on this other camera here. In fact, I think I can make it big. Yeah, so hi over there. So this is the stack of boxes of parts that I have pulled out. It's not even actually, there's like 4 or 5 more over back on the corner here. These are just the most useful ones. I think I have to go back to, is it in my box of PCBs? No, I think it's in my box of future experiments, I think I called it. Oh no. Okay. Hello, we're back. So let's see. I hope it's in here. Maybe it wasn't PCBs. Maybe it's in assembly components. Let's see. Hobby servos, previous versions. Let's try this. If I can't find this in the next 30 seconds, we'll move along. But the couple of ways that I've been pursuing how to address these little tiny lights. Maybe it's in here? No, not in there. See, I really would have thought it would be in future experiments or PCBs. Old 3D printed parts, PCBs. Let's look there again. If I can't find the assembled version, here, I'll just show you the circuit board. You'll get the idea. Jeff took some time to take his arms off. And, you know, Dave, you're not wrong. But I feel like that's maybe a little bit alarming. The pile of boxes grows over there. So I'm not, like I say, I'm not sure where the assembled version of this is, but it's just a prototype anyway. Here, let's get a little bit closer there. We'll zoom in. If it'll focus. Yeah, so the idea is there would be a little dip switch here, as Chris says. And my original thought was that you'd have this module, it would be connected to a battery through the power and ground terminals here, and then you would use the same 4-pin interface that the light has to program its address. And this module would provide power during addressing. So, you'd power this off of a little, maybe 2 LiPo batteries, like at 7.4 volts. You'd have your moving light controlled by this board sitting on a table somewhere. You would set the address on the dip switches, then you'd plug this in, and somehow, and this is kind of the, this would be looking for a DMX signal, but if it didn't see one, it would ask for the data that was being communicated by these dip switches by a couple of these shift registers that would be on the back. And it would shift in its own address and absorb it. And then you'd unplug your programming module, plug it back into the operating cable, and you'd have your light addressed. That was my thought. It looks for an address or DMX on startup is kind of a kludgy way to do it. So I feel like going with an RDM solution where, you can use sort of any environment to just program an address into this light. And I could probably make a little tiny RDM transmitter in this kind of form factor anyway. That's just it's just less kludgy. But this did turn out, this did kind of work. It was the heuristics of how does this tell if it's getting a DMX signal or a whatever signal this is putting out. That was a little bit hinky, as they say. In any case, programming these little tiny boards. That was all a diversion to talk about DMX addressing because we were talking about how the Arduino code works. And like I say, really simple, right? We're turning on our DMX library. We're telling it to be address 1. In this case, we'll just hard code it to 1. We set our various pins to be outputs where we need them. We attach and enable our servos. And then all we're going to do in our loop that we loop forever in is DMX value 1 is going to be our intensity. So it's going to get analog written. It's going to be pulse width modulated out to the LED pin. And our servos will move to the positions specified by DMX channel 2 and DMX channel 3. That's the whole thing. That's the end of the code right there, right? So whatever I see on DMX channel 1 is how bright the light is. Channel 2 is pan. Channel 3 is tilt. Bada boom, bada bing. Super easy. How do we get that code onto a board that is not, as you recall, an Arduino? It's a little tiny circuit board. It's funny. It's like, I feel like when we're way zoomed in on the table, these feel huge, and then you see them in real life, and it's like, ooh, that's like a little potato chip of a thing. So we're going to program that through this ISP header here, which contains, in our little 6-pin connector coming off of our programmer, power, ground, a reset signal line to tell the microprocessor here that it's going to be programmed, and then signal lines to actually pass the data into it. So what I'm going to do is I'm going to attach this to our ISP header here, and you can see on my solder mask I have the little nose hooking out there. That corresponds to the little nose on the connector there. I'm going to plug those two in, and if all's gone well, yeah, so I have a power LED there, just to let me know that the thing is actually receiving 5 volts. And let's see, programmer still active. What I'm going to do is come over to the computer. I'm going to say in my tools library, and I know this is awfully small, but there's no way to zoom this UI in, so I'll just narrate it to you. I'm going to select the programmer that I'm using from the tools menu here to be USB Tiny ISP, which is the one I'm using. And then I'm going to first burn the bootloader to it, and we'll see how this goes. It says reading, it says writing. So basically it writes the bootloader out, then it reads it all back to make sure that it's been written correctly, and then it says done. Well, that worked. Hey, it worked. We can celebrate that. Yay, a thing worked first time. That's very good. As regular viewers know, I'm going to ask for questions at this point, which really just means I'm thirsty and need an excuse to take a drink of beer. But questions? There's so much schmutz on this table, it's hard to figure out where the beer goes now. And we're unmuted, which is another win. All right, so now we have our bootloader loaded, which you'll recall from the Making It Permanent episode of the Electronics Bash, is the extra bit of code that lives on the microcontroller that makes it easier to upload further bits of code later. It's actually a little bit redundant for what we're doing because we're not uploading code over the serial terminal like you would in an Arduino environment, over the serial port. We're always going to be loading it using these programming channels. But burning the bootloader also sets all the various internal fuses to the places that we want to be. And fuse in this case just means a permanent bit of configuration, right? So things like the code and the data can change, but we've now burned the fuse that says run at a 16 megahertz clock rate as opposed to 8 megahertz or 1 megahertz or what have you. Enable brownout detection. If you lose power, assume that you should restart the next time you start up. Those settings are more or less permanently stored in the microcontroller now until, of course, we change them. And those permanent configuration settings are called fuses. So burning the bootloader burns the set of fuses that I want, and that's a very handy thing. To test whether this is working in a really easy way, I'm going to load up the Blink sketch here from the Arduino IDE. Wow, this feels like old times, huh? Rather than blinking LED 13 on the circuit board, I have a built-in LED on a different pin. I don't actually remember which pin it is, so I'm going to load up the schematic and we can look it up together. So the schematics, I know I did an evening on like building your own circuit boards, which is episode 9, I want to say, of eBash. So this is Eagle PCB tools. If you were going to go out and learn a PCB tool today, I'd actually recommend starting. I mean, Eagle is great. These days you might want to start with something like KiCad, which is open source, and constantly improving. You get a lot more features for free. You also get a few more bugs, but it's a really cool piece of software. I was going to look up, okay, so there's the symbol that represents our microcontroller, and I was going to look up where this LED is attached. So that is hooked to the MOSI pin, which is also pin D9, D10, so that must be on digital pin 11, what the Arduino environment would call digital pin 11. Let's close that up, and we'll go back to our blink sketch, and I will set pin 11 as an output, and I will blink digital pin 11 if all goes well. 13 says here, Chris, thank you for being my reference librarian on this one. I should have a list of these here. I mean, I don't know how many people actually go back and watch them after the fact. It tickles me to like, be like, oh yeah, we talked about that. Anyway. So all this code's gonna do is gonna turn pin 11 on, wait a second, pin 11 low, and turn off. In fact, let's make this faster. Let's make this 500 milliseconds per. And then rather than just hitting my upload button here, I always have to either go into my tools, into my sketch menu and hit upload using programmer, which is one of these options up here, or hit Control-Shift-U for upload programmer, or hold down Shift when clicking the program button. And if all goes well, we're compiling, writing, reading, done. And if we come back to the table, we should see, hey, there we go, look at that. That's awesome. Yeah, so that's digital pin 11 flashing away. So that means we have control over our little tiny microcontroller there. That's so cool. Let's see. Nate's been going back and building projects from the earlier streams. Built an adjustable power supply. Ooh, that's such a good and useful project. And got 2 shift registers lighting up 16 LEDs. Nate, that's awesome. Yeah, it's also really cool that like that's a very analog project and a very digital project, right? Like that's awesome. So this is very good. So this is just like, can I upload code to the board? And I can, which is great. So let's upload the real code, and then we'll get to it's assembling this and controlling it. So come back over to computer land. We'll load up our DMX moving light code. And again, I'm just going to hold shift and hit program. And with a little luck, we'll see, because this LED is attached to the same pin, the MOSI pin, the master out serial in pin, you see it glow during the programming process, and then it turns off. Palmer's really oh, interesting. Yes, right, because the camera's over here. Palmer's really enjoying the stream. Thanks, Palmer. Yeah, it's fun for me too, like just to have a more casual, like let's work on a thing time, as opposed to a more structured, classy time. It's a fun balance, I think. I don't know. Maybe it's a one-time thing, maybe it's a many times thing, but it's fun to be able to like just like talk about nerdy stuff. So now, in theory, this has the code for the moving light loaded on it, and it's waiting for DMX instructions to put them out over these connectors into the LED. So let's finish assembling this and see if that works. I'm going to set the programmer aside for now and try and do the next steps in the right order. So I am going to need to solder on these 2 LED wires to the circuit board here. So you can see there's 2 pads that live between this big surface mount inductor and the servo headers where the LED gets powered. And when I was soldering these LEDs together, I color-coded one of these wires black to, I believe, indicate hot, but I screwed this up so much that I'm actually gonna strip these wires back and use my adjustable power supply to test that I got this polarity right before I go ahead and solder them down. So I'm just going to strip off a little bit of that. I'm going to use my proper strips, I think. This wire's a little bit waxy, and it makes it hard to strip with those flush cutters. Chris says, when does the RGB version get released? So interesting you should mention that, Chris. I've been toying with an RGB version. There's a few challenges, as you can imagine. And maybe as I'm plugging in this LED is a good time to talk about how these lights are actually being controlled. Well, let me test the LED, and if there's fire, we can focus on that. I'll turn the voltage down there. There's an adjustable power supply, you can't imagine off screen here. And I'm going to, I'll turn the current all the way down. I'll turn the voltage up, and then I will dial the current up. There we go. All right, so polarity is correct. super duper bright. So this is running at 230 milliamps. So a quarter of the current that this is capable of. It's blowing the camera way out, which is very cool. Yeah, these things are bright as beans. But I'm glad I have the polarity right. And Jeff burns his hand. Yeah, not yet. Oh, this is like, that is warm. That is noticeably warm after just a few seconds on. So maybe a heatsink's not an awful idea. I mean, I think in the kit version of this world, I think they come with a little heatsink, just to help with heat management. So I'm not going to get the full vise back out. I'm just going to thread these two wires back through the circuit board. And I will solder them in place. This isn't any kind of fancy wire, by the way. I have like 500 feet of like 24 gauge wire that I got from a surplus store in California ages ago that I just use for a lot of small wire projects like this. Maybe someday when these are a kit, there'll be some choice to it. Chris says, hole in the lid, or is there a slot for wire? What a good question, Chris. What am I... Chris, you're saving my bacon. Yes, before I solder these in place, I'm supposed to thread them through this hole. Ooh, Chris. I don't know how Stream actually do, but if there were like a way to like give you superpowers for 5 minutes, or like make balloons pop up that honor your name, I feel like now would be the moment, because you saved my beans right there, Chris. You saved my beans. All right, so that goes through. This worked so well a moment ago. That goes through that. The other thought I've had is, like, specifically because this is finicky, maybe this gets connectorized before someone else has to build it. Like maybe there's maybe the LED comes pre-soldered to a connector, and there's a little through hole, like mini JST connector here, that you just plug the LED into. And then actually that might be kind of cool, because then it would allow you to like change out the LED. So I think this one is like a 400 Kelvin, like medium white LED that I just pulled. They come in everything from like 2700K to 6500K. So maybe having the ability to choose color temperature would be fun without having to resolder and desolder things. All right, that's better. All right, so now that's already pre-threaded through that hole, thanks to the heroism of Chris Wick. Thank you, Chris. So now the servo header, the tilt servo header, also threads through that little hole in the 3D printed base, and that's going to plug into the tilt socket here, and I get to remember which orientation it goes in. I can tell by looking at one of these other circuit boards and seeing that, so the outermost pads here, I need a pointer. You can see the outermost pads here have these little like semicircular little arcs around them. That's little places where the copper has actually been pulled away. So all this green area underneath is a continuous copper plane that is connected to ground. All the connected green under here is ground. And if you were going to try and solder to this ground pad, you would have quite a difficulty, because you'd end up sort of heating up all of this copper on the bottom side. So what a lot of PCB design softwares will do automatically is what's called thermal reliefing, that just carves away a little bit of copper in that corner and a little bit of copper in that corner and just like gives you a little bit of space so that the thermal conductivity of this specific pad is less to the rest of the board. So you have to heat the whole darn thing up. And because it exists on these two outer pads, I know that those two, the outer ones on my circuit board, are the ground pads. So I'm going to plug in my servo header with the brown wire on the outside here. That's the ground wire. And actually, why don't I'll do the tilt servo. Let's see, I'll do the pan servo first, because the tilt servo is kind of going to have to jam in there between the two, because I've got my Leaning Tower of Pisa power module there. So that's those connections. So now this would be the point, if we were writing formal instructions, when this would get screwed down to the board in here. But as we discussed earlier, screwing it down is not going to happen this evening. So with a little bit of sticky tack through the box, Chris, I'm not quite sure I understand. Have I screwed something up? I hope not. The Pan Servo doesn't have to go through the box because it does have a cutaway in the lid. That might be what you're saying. So the Pan Servo here comes straight down to the box from the Pan Servo. The Tilt Servo is the one that has to come in from the outside, at least in the current version. So I'm just gonna feed back a little of that slack to here. Yep, got it. Pan Servo. Good, good. Thank you, Chris. I will. You have earned the right to say stop, Jeff. Please. What are you doing, Jeff? So this mechanical interface, obviously down in there with sticky tack, is going to be a little bit squishy for today. Not like a metaphorically squishy, but literally squishy. But you can see that's where the wires will plug in, the connector will plug in just a little bit here. That's normally where the screw header would screw down. Okay, so now we've come to that point that I said we would get to where we need to actually squash this lid in place. And you know, I think since you all enjoyed it so much earlier, I'll give people what they want, which is some more filing. I know, I'm too good. Dumb. So part of the issue I will totally totally confess is tight tolerancing, and part of it is that this is of its nature a little bit of an overhang in the lid, and so you do get a little bit of droop underneath there when you're printing it, and that's certainly not helping clearances any. Honestly, the fact that circuit board isn't screwed down might help us with clearance here. For those who are just joining us, like Becca, I didn't think about how tall this replacement power module was when I swapped it out for what I had been using, which was one of these short little guys. So now I'm having clearance issues. Oops. All right, so now these are, oh, you know what I did forget, but I'm not going to go back and do? That's all right. Is I bought some of this stuff, which is expandable webbing, which goes over, it's meant to go over the LED wires and the servo wires coming from the head. And this would probably come in a kit too, maybe in a different color. Maybe I wouldn't care. Just to like clean this up a little bit. I actually, where's the version? Yeah, so like here's version 0.81 that has that tail on it. I think that looks really classy. Well, not really classy. I think it looks better than wires flopping about all over there. Catgut, yes, exactly, Nate. It looks really good. I'm not gonna. I should have done this. This is what I should make an order of operations. Yeah, I got nothing. But this would be a thing I'd have to do before soldering the LEDs in and plugging in the servo and various things. Yeah, for sure. I need to. I should. Even if I never end up releasing this as like a kit, I should write up some instructions because clearly I need them. All right. So now we're just going to slippy slide. Or creamy cram that lid. Ooh, it's gonna be a tight squeeze with that. Gonna give it some mechanical assistance here. Maybe come in through. If this doesn't end up fitting, we can either bodge it as Palmer suggested, and I can reprint them for version 0.92, or we'll just leave it like this because we can still do all of the programming and playing with DMX with it in the kind of half open state. It just won't look as good. Well, that's kind of do you say why a slide lid versus a screw down lid? Yeah, Chris, just for honestly for finickiness's sake. I originally did have a a screw down lid, but for the size of lid that I wanted to use, like for how small I wanted to keep, yeah, this is gonna be a bit of a bummer. For how small I wanted to keep this, I was working with like M2 size, metric size 2 threaded inserts and screws. And what I've discovered is not only are they finicky even if you buy the nice ones, but quality control is a big issue because the threads are so small. In fact, here I can show you. So this is an older version. You can see I'm holding the corners down here with sticky tack because underneath there are, you can kind of see where they would be meant to go. Let me zoom in here. if this will focus on a white thing. There we go. So that's where an M2 size threaded insert is supposed to go, but they're so small and fiddly that getting them aligned, even in a small device like this, is really tricky. And I went through 3 different brands and didn't find them to be at all consistent with how good their threads were. And so even if I was going to find like a brand that fit and M2 screws that fit them, it just doesn't feel like a thing that like either I have a hard time dealing with them. I wouldn't want them to be the method that goes out into the world. So that's kind of why I've gone to a slide-in lid, at least for now. Like I wish it was a more secure mechanical fastening. I mean, this isn't going anywhere for sure. But yeah, we're not gonna see how we're so close. But with more filing we could get there. But I wouldn't do that to you. Chris says wood screw instead of insert, like secure the box to the board to the box. Oh, you're referencing like attaching the circuit board to the PCB to the 3D printed base itself. Same reason, fiddliness. Like I could fit an M3 insert in there, and I should try that actually. I've gone from M2 to M3. I should try and see if that works. But precision with those threaded inserts, because you're melting them in probably with a soldering iron, is tough. And a screw that goes into a pre-started 3D printed hole is just going to be more precise and, well, I don't know about stronger, but just as easy for an end user. So I'm going to say that that's as far as we're going to get this close for tonight, but that's going to be fine. I'm just going to put the cover on, and if you look at it from this angle, it looks great. I mean, I think it looks fun even without. One of the things I'm also working on is I've already done some updates to how the 3D printed star mounts inside of here, just to keep it a little bit more centered. But this version, 0.9.1, does not have that, so you can see it's a little bit off center there. The lens actually helps quite a bit with that. Let's attach the lens there. There we go. And you can see it's fairly far recessed down in there, and that's just because there is room, like I say, for a heatsink, and I'm not quite sure how to handle that in a situation where you don't have one. So there's that. So that's our little 3D printed moving light. I mean, of course, with all the mistakes that I've made, should have this cover on here. You know, maybe we think about putting the heatsink in there, and of course this would want to close. But like this is why you know I thought it'd be fun to do on stream, because it's more fun to see like how things got screwed up and how we might fix them. Thanks, Becca. Yeah, isn't this? I'm having a great time with this. So let's. I think we should get this turned on and dancing, right? I think that's got to be the end goal. So let's zoom ourselves out a little bit here. Chris asked a really fair question, which is how do I number major versus minor revisions going from 0.8 to 0.9 and 0.91? So the good answer is if I'm making a revision because of an error in assembly or manufacturing, let's say, it's a minor revision. So version 0.9, which I don't have any of because there were errors in my manufacturing, version 0.9 with minor changes to manufacturability became version 0.91. The differences between like beyond that, like what is a minor and a major version, is kind of academic. I mean, really, in my mind, everything is a major. For every time I redesign the circuit board or the 3D printed parts, it's a new major version, 0.8, 0.9, whatever. Every time I have to change that design ethos because I screwed something up or I've manufactured it wrong, that's a minor revision. It's kind of arbitrary. And now that I'm at 0.9, I don't want to go to 0.1 until things are released. Maybe I do. Maybe when this iteration is done, you know, when the clearance here is right and it's assembled right and I have a guide, ooh, that's a good idea. When I have a written assembly guide for making a version, I will number that 0.1 in honor of having a plan, let's say. Let's get this thing moving, huh? Let's get the thing moving, and then maybe we'll put some hanging hardware on it. That would be fun. So to drive these things for now, so these things will take just bog standard DMX out of a lighting console or a node, or, you know, it literally just, you know, standard ESTA, what is it, 1.13? What is DMX? 1.4? DMX 512A, right? We'll come in here just fine. Technically, I'm not, of course, being standards compliant because I'm not using a full-size XLR connector, and then because I haven't labeled this like there's in the DMX standard, there's a thing you're supposed to say like, you know, non-standard connector anytime you're using something else. I haven't done that. I'm not too worried about it. I'm also sharing my data common line with my my negative power rail, which is not really standards compliant, but again, it's a 3D printed moving light. Like, what do we want to do? So since I don't have a light board at home, although I would love to have one, what I have, of course, what I do have is a lot of Arduinos. And so I have this kind of Frankenstein-y solution to get DMX and power into this device. But before I scare you with that, let me talk just a little bit about the cable interface that actually gets DMX and power into these things. E111, thank you, Chris. Yes, DMX 512A. I did a whole write-up on lighting control protocols in my blog at some 1.2. Jeff.class/blog. It's somewhere back in there. DMX and RDM and SACN, various things. That was a lot of fun. I think that was the one, Palmer, that you mentioned AMX on, or CMX, which is a blast from the past. So these are the cables that I'm standardizing around for the Demilight project, at least for now. What these are meant for is driving RGB LED tape like you see behind me on the shelves here. So they're not fancy. They basically, you may have seen these if you've ever bought RGB LED tape. They just have a little female 0.1-inch header internal to them, and they come with these little male-to-male headers in case you need a male head on them. You just press that in, and now you have a male end on that cable. They're not fancy. They are, but they're cheap. That's the whole point. Is like you can buy a pack of these, you know, from Amazon for a few bucks, and from overseas for, you know, very few bucks. And you can get them in all kinds of interesting configurations. You can get long cables, you can get short cables, you can get splitters, which we all know for DMX, Y splitter is a no-no, except that in the RS485 spec, at 250 kbps, which is what DMX is, your maximum permissible stub length, your length you're allowed to deviate from a straight line path, I think is 19 feet. Something like that crazy. So like a little tiny Y splitter, like one of these that I totally have prepared and standing by, is not going to be an issue. And is going to really simplify our kind of hobby wiring for things. So like here's a little 1-to-4 splitter like you might use with LED tape. Is it standards compliant? No. Are our cable distances incredibly short? Yes. So like these have worked fine for me in short line testing. Presumably, if you, yeah, it will be fine. And if it ends up not being fine, then anyone who's running into that problem can probably solve that issue. So the way that I'm getting power and data into these lights, and if I could, here it is, into this light, as I said earlier, is I've got power and ground on opposite sides. Let me zoom you in here. Zoop. Power and ground on opposite sides, and I have reverse polarity protection in this diode right here. So you're meant to plug it in with the arrow pointing at the V+, and probably the labeling on the PCB and the light itself could be stronger here, so there was a little matching arrow. But if you were to plug it in like this, so you had power and ground reversed, this diode, this little low, the Schottky diode here, would provide reverse polarity protection and would prevent you from blowing anything up. So nothing would work, but you can't damage the light that way. And similarly, in this scenario, you have your plus and minus DMX polarities reversed here, but again, your board's not on, so who's going to care? So what I need is a way to get a DMX signal and plus 12 to 24 volts onto a cable like this. And for that, I have built, there we go. I have built these little boards. These are not a final product by any stretch. They're just kind of convenient. All it is a little, 4-pin header to match these cables, right? So they just plugs in, bloop, just like that. And then a variety of ways to put your DC power onto those rails. So I have a 2.5 millimeter barrel jack. I have little screw terminal headers. I have some other large pads you could solder directly to. I mostly just shove wires in the headers and then connect this to my power supply. These are really meant as like a prototyping tool for me. I was like, I'm not sure how I'm going to get power into these boards in any situation, but this is a useful way to do it. And then you have pads here. You have two sets of pads for the actual DMX signal to come in. So you have a signal ground, a signal inverted, and a signal non-inverted. So into this board, you could put any kind of DMX from, like I say, a console, a DMX node, what have you. I am using, because I have, all this hardware that uses Arduino technology to make DMX, I'm using another Arduino Pro Mini and actually an earlier version of the Demilight shield as a DMX output device. And that, the rest of this nonsense is just like a convenience of what kind of connectors I often need. So my DMX output device really is an Arduino, a programming dongle that hooks up to the computer, and a 3-pin XLR male, in this case, connector. And then I built a long time ago this device, which has a 3-pin male, a 3-pin female, and 2 sets of header blocks, all hooked up to the same 3 wires of DMX, so that like whatever kind of connector I have, and I often prototype with 3-pin just because it's cheaper, I can say, okay, I have a 3-pin male I need to plug in, and I have some bare wires I need to plug in, and I have all the connectors I need. So it looks kind of like a Frankenstein mess, but it does the job. Yes, I know it's supposed to be 5-pin, but 5-pin's expensive, and I'm a hobbyist. Yeah. Anyway, that was gross. Hang on, I feel like it's time to ask for more questions. And remember to unmute, another feature. All right, so let's get this thing running here. So let's see here. So first, I think before I plug this in, I'm going to flash my control code to this Arduino Pro Mini. So let's come back to the Arduino IDE here, and we'll open up our controller code. And again, like I said, you don't have to use an Arduino to control it. It's just generating DMX in a way that's convenient for me. But much like before, I'm using the Conceptinetics library, but in transmit mode this time. So DMX master, in this case, .enable. There's a pin on the little control board that controls whether the Max 485 is a transmitter or receiver. So by turning on a digital pin attached to it, I can make sure I'm in the transmit mode of the transceiver. And then I'm just going to loop through, I'm going to loop forever. I'm going to update a variable that keeps track of the current time elapsed since we started running. And then I have a variety of ways that I can map that time value to a state of the mini moving light that I might like to see. So I'm not changing this switch statement at all, in so much as like I'm just using this switch statement to select which of the things I'd like my one moving light to do. So if this is a 0, then every time I go through this loop, I'm going to set my intensity to O2, so a little glow, set the pan to 90 degrees and the tilt to 90 degrees. So the thing will just turn on a little bit and point straight up, which is probably where we should start, so we can, as Chris said, zero out where those servos should be and make sure that like home is home. And then we can get into some other control modes here. So let's start with that. So we'll set this to 0. And in this case, right, I'm not using my programmer. I'm using my attached Arduino, which is a Pro Mini. It's on COM port 3 probably. Let's come back to the table here as I hit upload, and hopefully we will see. Well, hopefully we'll see that upload. We may not. Let's see here. This is one of the things I did not try out beforehand, but it seems to be having trouble uploading. Why? Oh, I know why. Okay, this has burned me a bunch of times. Chris, Nate, Palmer, this is the kind of stuff that you call me on during streams, and I'm gonna say it again. You may remember this from back in the day. So because the DMX software is basically using the built-in serial port functionality of the Arduino to get its job done, I have to have a little physical jumper on these boards that switches back and forth between, if you can see there, enable and program mode. If it's in enable mode, it will output DMX, but I cannot program it. If I'm in program mode, it will not output DMX, but I can program it. And so many times during this process, mostly not on camera, I've been like, why won't it program? I can't figure it out. And like, oh, it's got a physical switch on it. And then later on, I'm like, why isn't the light turning on or moving? It was just, oh, I haven't flipped this stupid switch. Very silly, very silly. It's one of the advantages, frankly, of using the ISP programming functionality on this board, because you're programming it not using the serial headers. So you can program these even while DMX is coming in on the serial port, because you're using different pins. But this is an older device, and it does not have that functionality. And Yeah, it's pretty rough. So now we're in program mode. Let's plug our programmer back in. We'll plug it back into this USB cable. We will hit program again. I'm just going to configure. I'm not going to take you back to the computer. You get the idea. We'll hit the COM port. It's a Pro Mini upload. Hopefully this time we'll get some blinking lights. Yeah, there we go. Twinkle, twinkle, twinkle. Twinkle, twinkle, twinkle. And so now in theory, this will be outputting DMX. In fact, let's take a quick peek at it and make sure it looks like DMX before we plug it into the light. Just to draw this out a little bit longer. Just a little bit, but we're almost there. Let me turn on my oscilloscope and then figure out how to show you my oscilloscope. Which I think I can. I have done this on stream before, I know. And I think it involved basically swinging one of these webcams around. Oops, unless I have robbed my oscilloscope of power in the meantime. Stand by, please. You've now come to the audiobook version of this evening's Moving Light Building session. Oh, that's fine. Don't mind that sound. That's a perfectly normal sound. Let's see. That IEC cable is gray, and it goes to this point here, and it goes back there. You would be, I apologize that you're not getting to see this part, but you would be looking like up my nose at this point. I'm all back in the guts of this setup. Yes, so that plugs in there. That leans back there. The oscilloscope turns on. Jeff unknocks over his monitor. Sets it back up so everyone can see his lovely face and he can see their lovely comments. Turns the monitor back on. And we're back with this cable hanging in the space here. It's all going so well. But yes, well, the oscilloscope is now working. Just want to show you what DMX looks like. I'll swing the other webcam around here, and then I think I can show you. Yes, a little bit of glare there, for which I apologize. But I think we actually might be able to help that out a little bit if we do that. That's a little bit. It's gonna be a quick demo anyway. So over on the table here, I have my my DMX lines that will be going to the device here. I'm gonna take my scope probe and I'm gonna clip it to just one of those data lines. Really, I should clip this. No, that'll be fine. So I'm gonna ground that side and that side, and I'm gonna probably need to adjust some of the timing here. So what's our timing? 500 milliseconds per division? Looks like that is, oh, you know, scope cam needs focus. Yeah, let's bring that up there. It may be a little bit confused because it's trying to focus on a screen. It's a little bit closer than it's wanting to. That'll get us close. So as always, I have forgotten to switch us over from program into DMX output mode, but when I do, there we go. We should see our DMX signal flowing by. I get this to trigger. Let's trigger on, let's see here, trigger menu, source type edge, source 1, rising, trigger mode auto. Why are you not triggering? Let's do unit menu 1. Let's do DC coupling, channel 1 on, not inverted. Let's force trigger. Interesting that's not triggering on this, but that's probably a problem for the other day. But yes, that's we get the idea. That's DMX there. Data flowing out down the line. We can speed it up, we can slow it down. It's all going well. But that's a good, like, you know, proof of concept. We have DMX coming out of the thing. I hope it was worth like 30 seconds of I guess it wouldn't have been tummy cam. It would have been like nostril cam. But that's all right. But here, you can come back and look at my pretty face this time as I swing the computer webcam back around and turn the oscilloscope off. All right, so we have a good sense that there's probably actual DMX coming out of the device, which is good, because that's not always the case, as we have seen. And now that I repositioned my monitor, not that it fell over, you don't need to worry about it. Let's come back. Let's get the light back where the light was. We'll get the light back over here where the light was. And we will finally hook up this mini moving light and get things moving around. So I can actually do this part live. So let me get that cable back out. Move that off there. Move that out of the way. So here is our interconnect cable. So I'm going to plug it in with the arrow on this cable into the little interface board here with the arrow on V+. I'm going to plug the other side into this board here, but nothing should be visible yet because, of course, we have not given this light DC power. We'll just have given it DMX. Oops, that's popped out there. All right, so nothing moving there. That's not surprising. So now I'm going to need to apply 12 to 24 volts DC to this guy. And I will, using my bench power supply again, just off camera here. And before I connect it, I'm going to reset the current and voltage limits to be, let's say, 14 volts and some amount of amps. Let's set it to a slightly smaller amount of amps, just so in case something catches on fire. And if we touch this, oh, nothing happens, but it's come unplugged again. That's fine. So let's get that power hooked back up here. This is things have been going okay so far, but it's certainly possible that this is the point where they go wrong. Hey, there we go. Ooh. Well, it's certainly trying to move, which is interesting because I thought we set it to be static. Well, it's cute that it's moving. It's not really what I wanted it to be doing. Let's unplug that for now and see what's going on in that DMX master code. I'll move a cable that totally didn't fall on me out of the way. There we go, and we'll come back over to the computer. So what's happening here? So switch, I had this switch statement here that should be saying switch 0. Did I remember to re-upload the DMX code? I thought I did. We'll switch it back into programming mode. We'll upload and see what happens. Writing, reading. Yeah, that should do it. All right, well, let's switch back to DMX output mode. Yeah. Come back to the table, plug this back in. You know, it's still doing a ballyhoo. That's weird, right? That's weird. Yeah, I'm not sure why that is. So I have this, maybe I'm just missing how the switch statement is happening here. Well, you know what I will do just to be lazy is I'm just going to comment out everything that's not what I want it to be doing. So I'm going to put a single comment on the switch statement itself, and then I'm going to block comment out. Oh, you know what I bet it is? I bet I know. Yeah, So some of you may recall from a lesson that some cool guy taught you a while ago, in the switch statement here, I actually need a break statement at the end of each case. What it was doing there was it was saying, okay, this value is 0. I'm going to start at case 0. I will do this. But because I didn't have this break statement here, it didn't know that it was supposed to call that the end of its choice. It was like, okay, well, I'll set the intensity to 0 and the pan to 90 and the thing. And then there's just some more code to run. I'm going to set the channel value based on the value of these sine and cosine functions. Oh, and now I've hit a break statement. Now I'm done. So what I really want is a break statement at the end of this case so that it does this and says, okay, that's it. I'll go to the end. And then I'm just going to loop around again doing nothing. Mystery solved. All right, set this back to program mode. Upload. Ballyhoo's on first? Palmer? Really? Palmer, you have a master's degree. That's pretty good. All right, so now that's programmed. We'll go back to DMX control mode. Am I mean tonight? Am I feeling mean? I don't know what's going on. Oops, is that right? Yeah. Okay, so that's 90, 90, 90, and 2% light coming out. That's pretty good. So what I will do now is unplug this, and as Chris said earlier, I'm going to now reset this to the middle point of my of each of the ranges of pan and tilt. At least I would if I could. Oh, there's my screwdriver. Jesus. So now I'm gonna pop the aesthetic side of this off just because it's easier to work without it on. I'm gonna loosen this, pull that little screw out, and I'm gonna pop that body out, and then I'm gonna orient this straight up because that's what I want to be the sort of midpoint of my tilt range. I will screw this back in. Screw that in there. Boop, boop, boop. There we go. So that's going to be 50-50 tilt. And then pan actually looks pretty good. That's going to be middle of my pan range. It's not perfectly at 90 degrees to the body there, but for government work, I think that'll be good enough for tonight. My servo cover is also, I think, a little bit tilted. just because of how I crammed it into the base there. So that's not ideal, but that's all right. For the sake of a demo, it will move freely, and that's where we'll get to tonight. And I'm fine with that. All right, so that's now reassembled. So now if I turn this manually, if I deliberately tilt it and pan it off axis, just gently so we don't have any of that servo slip, when I plug this back in, it should snap to, you know, more or less square and pointing straight up. Let's try that. Oh, well, if this end of the cable was plugged in, it would do that. There we go. So now it's pointing straight up, although you can still see that LED is a little bit off axis there. And, well, more or less square. Maybe I don't feel like fixing that because we have to take the whole darn thing apart again. So that's basically our home position for our light now, which is awesome. So now we can run some of our other test code and get this thing dancing around. So let's take a quick look at some of that other controller test code. So this was case 0 of our switch statement here, called straight up, right? Point straight up, be at home, right? If we change this to 1, we'll go through our loop. And what that's going to do is say, set the intensity always at 5%, but the pan and tilt values are going to change based on these formulas. So one's going to be 90 degrees, the pan's going to be 90 degrees, so center, plus 90 degrees times the cosine of the current time divided by 2. So every time our time unit loops twice, and that time unit is based on, you know, a division of the time elapsed since the program has started. Make sure, yeah, okay. Then it's going to sort of oscillate back and forth like a cosine wave would do, and the tilt value is going to oscillate centered on 45 degrees, so pointed forward a little bit, going to oscillate 30 degrees up and down at a faster interval. So we should get a little ballyhoo here as the thing moves back and forth and up and down in non-synchronous motion. So I'm going to set the master here back to program mode and upload this. Yeah, the connectors get a bad case though. Yeah, it's possible that, like, I mean, they are cheap connections, but they are not super robust. If I could find a cheap locking connector system that also had cables that were already being built for them for some other purpose, I mean, that's why I chose these. Stand by. That's why I chose these connectors, is because they're already being made by the bagillions for an existing market. If there is a market out there that has, like, existing cheap, small locking cables, I would be all about it. I haven't seen one, but I haven't looked recently, I suppose. So now let me switch back into DMX mode, and there we go. So now that, as you can see, that tilt value is oscillating twice as fast as the pan value, so we're getting that kind of figure 8 pattern. Right here, I'll hold it in a more, oops, yeah, more familiar orientation. So one of the oddities of having a top-down camera, right, is it's not quite how you would normally see these things. Beer break mid-sentence. Yeah, Nate, this is how we do things on casual nights, right? We just, you know, when the guy needs the beer break, he needs the beer break. I'm not going to try and hide it. Yeah, so there we go. So this is obviously moving quite slowly. Should we push it a little further and see how fast it could move? Here, so we'll take, one other thing I should probably increment is right now, so when I switch DMX off, right, when I remove it, the LED stays on, and as I'm thinking about it, it probably would be good for if you lose DMX signal for more than, you know, a certain number of seconds, the LED should probably turn off just to minimize heat. So we come back over to our code here. Let's see. What else did we define here? Cross probably moves in a cross, and circle. Let's go to circle. That'll be case what? Case 3. Let's see what I have it defaulting to here. Probably that same 4-second time period, I think, is probably what this is defaulting to. So let me switch this over to, after it's done programming, we'll switch this over to DMX mode. Oops, to DMX mode. Oh, it's not plugged in. Yeah, all right, this is kind of making your point for you guys, is that these connectors are just not particularly robust. Oh, and my power connections come undone too, but that's not the light's fault. All right, so that's doing a little circle with period 4,000 milliseconds. One of the RJ40, ooh, that's interesting. RJ45 or RJ11? It's an interesting idea. I mean, RJ11 is typically 4 contact. Do you like how there's a little light show going on me right now? Here, I will show you the light at the same time. But now we get a little moving light show. Am I on live chat or top chat? I'm on live chat. So I think I'm seeing everything. Palmer's referencing I had the chat setting wrong, so I was missing things previously, but I'm currently on live chat, so I think I see everything that's happening on YouTube. Yeah, RJ11's cool. It's well, yeah, to be honest, so what I was going to say is it's a little big for my taste, as I'm really trying to push for miniaturization, but as I'm thinking about it, right, now that we're committed to, well, not committed, but we have these big, chunky power in converters, how much bigger can that really be than an RJ11 jack? Yeah, I have an RJ45 jack here, or RJ45 at least plug here, and RJ11 is also cheap. Yeah, so what do I have here that has an RJ45 jack on it? I probably have a Raspberry Pi nearby. Yes, I do. Get the cheapest RJ45 jack. Here, let's just hold these up next to each other for comparison. So, I mean, yeah, we'd have to think some more about, like, board layout. So that's RJ45, so bigger than RJ11. And same width as my current cable. Yeah, it's not that much bigger or chonkier. It would take up more board space, right? I mean, this is RJ45, but, like, right now, thinking about that, that just takes up, like, a 2/10 of an inch, whereas we'd need, like, the full... Although maybe it's acceptable for this jack... If we found a jack that was able to hang off the board by a certain amount, I mean, we might be sacrificing a little bit of mechanical stability, but I don't hate the aesthetics of this light, and then there's a plastic block sticking out the side here where the connector goes in. I don't hate that. Okay, yeah, I'm game. I think this is a really cool... Well, not to limit us to, are there any other, like, locking cable types that spring to anyone's mind? I'm also going to put us back to here because I'm really enjoying the, like, having the light show on my face after the Unevening's hard work. Like, I thought about JST for a while, and I think there's, like, the JST connectors of various stripes are great, but there aren't that many bulk pre-made cables for them. Right, that's the problem. Is like not only what's the right connector, but what is the right what's a connector that already exists in an ecosystem that makes them cheap. Dave says, how to header with a lock? Yeah, so something like a 0.1 inch header with like a locking connector or something like that would work well. Something like a Molex connector, right, but smaller. Or a locking DuPont connector, right? Something like a servo header connector, but with a locking tab, right? Would be super cool. It just, and I might be wrong. It's like, do those already exist in various lengths in the wild, pre-assembled, which I think is a like motherboard headers. Yeah, something like that. Like what I spent a while trolling. It's probably been 6 months since I've done this, so it'd be really worth repeating the exercise. But trolling, like trying to think of like what hobbies exist that use cables kind of like this. Like, if the RC car market has 36-inch locking JST cables for such and such a purpose that they're already going to be using dozens of, awesome. Computer PSU cables is interesting, Palmer. What about not... Can I pitch a really dumb idea? What about eSATA cables? What about... Hang on, let's find some of these. This is a really... I mean, this is, I'm sure, not cost-effective. But they are small, and they're on my mind because I've been using them at work a lot recently. What about, like, hard drive connector cables that we just totally abuse the format of and put 24 volts across? I mean, that's fine. There is a power standard for them. We could actually be, format compliant. Use this SATA power connector. They're pretty big. Like they're 1.5 inches wide. Like that's too big. It just made me laugh to think of like you get this little tiny moving light. Ooh, USB-C would be classy. Yeah. Can you get really dirt cheap USB-C cables that just do like a couple lines? I'm sure they can. USB-C splitters is a good question, Chris. I mean, there's a world in which someday I make a USB-driven moving light, and now that USB-C is a thing, that could totally be a thing. But that's a whole different, architecture than this. So assuming we're using USB-C to power, anyway. Yeah, USB-C is a fun option. Like the idea of this is a desktop toy that you plug this in to a USB power supply, and maybe it has Bluetooth, and you like dial up an app on your phone, and that's how you control it. Like, is super cool. It's a different project than this, other than sort of the base mechanics. But I love that idea. Yeah, super cool. Let's keep spinning on this, because I think there's something here. I'm gonna, as promised, just get this speeding up a little bit just so we can see how fast it moves. Just because, well, this is the first build of 0.9.1, so I'm kind of curious myself. So I'm just going to, in the master code here, where I have this period of 4,000 milliseconds, I'm just gonna ratchet this up to shorter and shorter values, like 2,000 milliseconds, and I will upload that. Let's see. Josh says, can you only have one USB-C out on a hub? I wouldn't think that would be true. And split in this case, like not necessarily split power and like USB signal, but like literally like wire for wire split, like as if they were wire nutted together. So that's a 2-second circle. I mean, it's pretty juddery, but I think that's actually this servo because I've installed it pretty poorly. Why don't we try 1 second? See what happens. I gotta switch it back to program mode. And we're programming. Oops. Josh, now that Josh, I know you're over here. Josh, I know you can get I thought you could get USB-C to multi-USB-C hubs. Make a little opto splitter. Could totally do. Let's see. So that's in run mode. Oh, something's come unplugged. That's all that's happened here. Yeah, so there's a 1 second circle. Now we're really going. Look at it doing the thing on my face. How cool is that? Like, I have a little light show. I've played a lot with these over time, and like, but I'm not usually doing it on camera, so I don't see myself, and like having this little light show on myself is actually giving me a tremendous amount of joy. How cool is that? This is also, I think, I might be wrong, let's double check. I think this is only at 5% intensity. So let's class this thing right up. Let's slow this down to, a more reasonable speed, and we'll double check our code here. This is circle intensity is at 0.5. Oh yeah, let's kick that up. So let's take this back to program mode. Not doing the 8. Yeah, let's go back to ballyhoo, because that's the money. Let's double check what that ballyhoo is doing. So tilt at 45, pan at 90. 2 second ballyhoo seems about right. Oh yeah, because I did change it to the circle program earlier. And this will be 20% intensity. Let's program that and see what happens. All right, so it's programming, and it is, if I plug it in, running. Yeah, here, which way is centered on me? I think that is. Yeah, that's fun. Here, we'll turn off some of the bigger lights, and we can just enjoy the little light show that we've made. Yeah, look at that. Wow. It's that moment, like, I don't think I've ever actually seen myself, it's just cool. I'm just having a great old time here. That it's actually doing the thing. I think we got to kick this up to full. I think we got to keep this up to as bright as it goes. Because this is 20%. Like, this is, I mean, something might catch on fire, but that's all right. We have proof of concept. We know it works. Singe off your beard? Yeah, there is a chance, Dave, but like, if we're gonna go bright, let's go all the way. So where's our ballyhoo? Ballyhoo here. 5%? Is this still 5%? Did I change the wrong thing? This is still only 5%. Whoa. All right, let's make it 20%. Let's upload that. Oh, hi, Katie. Amazing. Fire warning. I do have a fire extinguisher nearby if we need it. Okay, so this is 20% brightness. Oh yeah, that's bright. So this is with, I don't know which lens it is. I believe it is a narrow lens. It's also, you recall, the lensing is tucked fairly far down inside the thing, but I'm probably, maybe 18 inches away from this light, and if I look down into it directly, there's significant after image on my face, which is pretty wild. So this is 20%. Before it was 5%. This is 20%. I think we go all the way. I think we go as bright as we can, and then we probably pull it out pretty max power, says the crowd. I think we probably have to yank it pretty quick because I do worry about heat. But we'll find out. So real quick, so we'll come back. We'll change this 20 to, I believe I want to set it here. Let's double check in our moving lights code. Analog right, DMX. So, okay, so here's what's crazy. So look at this code here. This is what's determining the intensity of the light itself. And then analog right to the LED pin, the value I get from DMX. Now analog right takes a value between 0 and 255. Not between 0 and 100, so I've been wrong. This was not 5% and 20%. What this is at now is at 20 out of 255. So what's that, 8%? We're going whole hog. We gotta go. Let's do the thing. Yeah. Do you have an escape plan, says Chris? I do have current limiting on my power supply. We'll see if that kicks in. All right, so we are uploading our code. You can see it writing in the corner there. Where's that screen? It's over there. Writing, uploaded. So when I flip this switch, we should go from 7.8%, thank you, Chris, to full percent. This is a great spooky Halloween shot. And again, 8%. Here we go. Oh, yeah! Look at that. We got a full, yeah, it's blowing out the webcam. That's cool. So I think, and I'm going to pull this in a second here because it's killing my eyes. I think I determined long ago, just based on like rough efficiency estimates and not off of any kind of lighting measurement, that, ooh, we're smoking. Well, we did see some smoke. Yeah. Smoke was bad. So, shall we see what smoked? I think we have to. Let's come back to this view so we can get as close as possible. Let's find out. It smells like electronic smoke. It doesn't smell to me like 3D printed part burning smoke. Let's see here. I'm not seeing anything obviously burning. I was pretty sure the smoke was coming from inside this. But I'm not seeing anything obviously burned. Right? Or I wonder if it was some of this plastic here where the LED would have been touching, because that's noticeably warm. That's quite warm. I mean, as long as we're here, and this, so okay, so let's for the grand finale, because I know we're going on, for those who've been here the whole time, 2.5 hours, and that's a long time for anyone, even if they don't have a delicious beer next to them. Because you read my mind. Yeah, we're going to turn it back on with the covers off and see what's happening in there. I will see how well this shows up on camera, to be perfectly honest. But we'll find out. Stand by. Yeah, so let's recap before we dive into grand finales, right? So we built our tiny moving light. It works. We have some clearance issues to fix. Jeff needs an instruction guide for himself because others will need it later, but he really needs it now. Don't forget to order those right screws, Jeff, and let's see what part of this thing it was that was catching on fire. So trying to think what's going to be best in terms of trying to be able to actually see this for anyone but me. I think this is going to be okay because I have a lot of light on the thing. And let me put the lens back in. Oh, you know? Oh, no. I was hoping maybe something in here was burning, but no, that looks pretty good. Palmer says, is the beer label upside down so we can read it while you drink? Maybe. It's like the Stone IPA, like, that's their kitsch for the no stone unturned IPA pack, apparently. Use case 1. Yeah, for sure. So that DMX code, to be clear, is still running. Like this controller is still outputting that exact same TMX. So when I plug this light back in, it should pick up, you know, right where we left off per se. I do have a fire extinguisher nearby. It'll be okay. And I have a big thing of water. Maybe I'll just take the lid off this. You know, I'll do the small thing of water because I have confidence that this will go fine. I have a small. This is my little bottle of water I keep nearby for wetting the sponge on the soldering station. What was current when it was running? You know, Palmer, I didn't look because the thing was on fire. And also, so it should have been running at about 1 amp here, plus a little bit more for stepping down to 5 volts for the servos and things. So here, actually, I'll tell you. I'll just run this briefly. Oops. Not plugged in on the other end. Yeah, okay. The point about connector choices is very fair. All right, so I'll plug this in briefly. I'll take a look at the power supply and see what current it's drawing, and then we'll go from there. So only 0.7 amps at 14.6 volts. So given that the forward voltage of this LED is probably about 10.5 volts, that's probably about an amp, which is right. Like this should be so there's a control line on the LED driver chip here, which is the AL8860 for those who are curious. If you tie it to high, if you leave it on all the time, you will run at 1 amp constant current out of the driver. If you ground it, you run at no amps, it turns off. If you pulse with modulate it, it will scale linearly in between. So even at max, this should only be allowing, you know, 1 amp current essentially through the LED. So let's put that lens back on just in case it was the lens that was burning maybe. That seems unlikely, but possible. Okay. So, enough stalling, Jeff. Let's get to the fire. Let's zoom. Let's see. I'm going to leave you a little bit zoomed out just so we can all be in this together. I'm going to increase my ISO so hopefully everything stays in focus really nicely. Could just be the oil. Yeah, it could be something to do with the 3D print. You know, just to make this a little bit easier, I'm going to make a small change to the code. I'm going to... and I'm really not stalling. I just wanted this to hopefully be cool and clear. I'm going to make this set channel tilt 90. I'm going to make it still, right? I'm going to not allow it to pan and tilt, so it just turns on at full, and then we can really see what's going on. Yeah, Chris, it could be just dust or oil. Did I screw that up? Oh, set channel value. Thanks, Chris. Set channel value. Set channel value. Let's upload that. Uploading. Okay. So we'll remember, as we always do, to switch it back into DMX output mode. Okay, so let's come to the table. So when I plug this in, it should turn on at full. It'll home, so it'll move a little bit, but then it should be static. And I will try and get this oriented up so we can all try and see, hopefully, what is going on. Fingers crossed. Here we go. I mean, it's bright as Dickens is what it is. And it doesn't seem to be on fire yet. I mean, here, check out the wall behind me. If it's on fire, I'll bring it back. Oh, it's on fire. Yes, I have little wisps of smoke coming from the area around the PCB, it looks like. Although maybe it's the wiring. It doesn't seem to be smoking as much as before, although maybe it hasn't been running as long. It shifted there. What is burning? Yeah, it's smoking, but not horribly much. All right, I'm gonna kill it and pull the star out, and we can try and see what's going on. Ready? Here we go. Well, I'm delighted that it wasn't. I mean, the star. Ooh. Yeah. So actually, I can't see much. I have a big splotch of bright in the middle, but you see that what looks like a blood stain on the back of that LED star there. So what that? Oh, look at that. The solder melted. The LED star got so hot the solder melted. No, Chris, not the cable, but the plastic, the PLA, right behind it melted. So it was sitting on that little lip of the PLA there, and it melted itself onto the back of the LED star, and it got so hot that when I pulled the star out, the two little soldered-on wires dropped away. Yeah, it desoldered itself. That's hilarious. Okay, so I know I said that was the grand finale, but maybe we could do a grand finale with a thing that works. One last thing. And if you have to go, I know some of you have Mr. Nefrata for chem next period, and that's fine. I know he's a stickler for attendance, but I have one more thing to try, which is that I do have some little, it's actually a little smaller than I thought it was, but that'll be okay, some heat sinks that I think might be worth trying. And actually, maybe I can steal one out of this older light. So heatsink, if we're gonna run it at full. I did have the thought, so originally, one of my thoughts was, oh, thanks, Nate. One of my thoughts was that I would so it would be pretty easy, based on the resistors on the board, to just cap this at 0.5 amp, right? So not the full 1 amp that the driver will carry and the LED itself will do, but just like, it's a 500 milliamp system, that gives us a lot of headroom. But if it can do 1 amp, or maybe it ships as 0.5 amp, if you want to overclock it to 1 amp, do so at your own risk. So this is not going to do the thing. This is a little tiny dumb heatsink. I think I can steal something better from one of these older lights back when I cared about like thermals and hope. Here, I don't have to do this off the side. I have a camera. Good gravy. Let's see. Yeah, that's the one I was hoping to use. So let's see if I can get this off here. So all this is, as I had some, they're kind of the perfect size. They're heat sinks that are left over from like a Raspberry Pi Zero cooling accessory kit that I had for a Raspberry Pi Zero project I was working on. But it is on there with the thermal adhesive, so it may not go on there. Have an LLC before I ship the kits. Yeah, it's not a crazy idea. I mean, frankly, it does like scare me a little bit, like shipping a thing that is like putting out, amps of power, and could possibly, have that smoke is involved is a little bit scary. So this is the heatsink I think I will use, and you can see I have this Raspberry Pi here. It's not quite the same, but it's meant to be a heatsink on top of your CPU there. Don't ship the LED, says Chris. I don't hate that idea. Where is my heatsink adhesive? I think it's up in Tummy Chem Zone. BRB, hang on. But I can leave the mic on. I can talk to all you nice people. It used to be when I walked away for Tummy Cam, I had to turn the mic off. But here, I'll give you the radio play version of this. I'll get you closer. I'll do the ASMR. So Jeff is now climbing up a small step ladder to get to the highest shelf of his shelves. And there he is getting some thermal adhesive with which he will stick a heatsink to the back of the LED. Josh McCammon, don't sue me. I'm totally ripping off your brand of ASMR in everyday situations. Oh. If you hear a crash, it's fine. I told you it was fine. So I think in here I have the thermal adhesive. Just use poster text as Palmer. No, this is the. I don't think so. I think that would burn even more. Send it with a T1 LED. Yeah, I could totally do. Not enough mouth noise. I have no. So I can't get. For some reason, Palmer, I should talk to you about the Scarlett 2i2. I'm having weird troubles getting in-ear monitoring working. So I don't know how that sounded to y'all. Hopefully it was not so awful. But I was able to recover my Type 79 heatsink compound, which is not an adhesive, but it is thermally conductive, so hopefully that will be good enough. So I'm just going to squeeze just a little dollop of that on there. And then, actually, probably shouldn't have put it quite so close to the center. We'll just smear that around on the heatsink. Whew. So one of the flaws in this plan, of course, is that, you know, if the LED was getting to that temperature before, this means that now essentially the heatsink will be getting close to that temperature. So this is not a flawless plan. Switch on front. Hit that direct monitor button. Oh, hello? Testing? Can I hear myself? No, for some reason I still can't hear myself. Anyway, that can be for Palmer and Josh. I'll watch your stream to learn how that works. Oh, I'm gonna have to resolder this LED. Because of course it desoldered itself. Maybe I'll leave the I'll put the heatsink on there just so it's not so crusty. Yeah, weird, right? All right, let's get this thing soldered. Let's get this thing, I mean, statistically back on fire, and then we should call it, because there's only so much. There is a knob with a direct monitor, but it doesn't seem to do anything for me, unfortunately. Oops. Well, my soldering iron was cooled down from when I thought we were done with it for the evening. So we will just melt this up. Melt that up. I probably should have used a little bit of flux on there. This is pretty crusty. Oh, that'll be okay. All right, so now the real question is which one of these wires is which? Because I know I labeled the end that was going into the board. Did I label these? Nah, not in your life. All right, so pry that back open and see if we can trace these wires back for science. So the positive's on the interior. So that's going to be this wire. It's going to be this wire. It's going to be that wire. So I think this is the positive wire. If this doesn't work, then I was wrong. So positive goes there. This is actually, so this is a helpful technique if you're soldering wire to like LED stars or LED tape or what have you. It's not good soldering practice, but it works really quite well. You put some solder on your wire, you put some solder on your device, and then you touch the two together and touch it with a soldering iron, and they just melt together. Well, you help preferably with a little bit of flux on there, if you can. Oops, have I bridged those? Yeah, I have. It's okay. I have desoldering braid, another great tool to have around, just to slurp a little bit of that solder. Desoldering braid, I'm sure many of you have seen. It's just a threaded copper ribbon, like a woven copper ribbon that through capillary action, when you heat it up, tends to wick solder away from a point. Dave's offering to sponsor me to have 2 different colors of wire. Dave, that's very kind. All right, I think that's right. Here, let's do a quick burn test, just with that LED hanging out there in space. And there we go. All right, so that was the correct orientation. 10 points to me. All right, let's put this back together, such as together is for this evening. Now with that heatsink in place, I think I could do the test in free air like this, but I think it's actually more illustrative if we do it. Ooh, Jesus. All right, so not burning hot, but like that's hot. I guess I was just soldering it. It's probably not. It's probably leftover heat from the soldering and not from the light. But still. Okay, well that's going to be close enough for tonight. Not a burn, just discomfort. All right, so that's kind of down in there now, close enough for this evening. And actually, as I think about it, I think I want, I'm going to orient this as it would be oriented with, like, so there's ventilation, so the heat can flow out these little holes. And actually, I guess this whole side's going to stay open, because I think it's fun for us to all see what's going on together this evening. All right. Everybody ready for the final, well, I know I said final before, what I'm at least this time calling the final burn test of the evening. You know, if something interesting happens, we might do another, but in theory, at this moment, this is final. Turn the soldering iron off, got the water handy. Let's do the thing. All right, let's get that out of the way, get that out of the way. Okay, and here we go. Not being terribly quantitative about it, right? Like I didn't time how long till smoke last time. It's also, of course, going to be resting in a slightly different place. It kind of looks like the heat sink is maybe resting on the plastic of the servo this time, which I don't know if it's going to fare better or worse. Just qualitatively, I have run these lights at full with a little tiny, you know, dumb heatsink like this for a considerable amount of time before, so I have a reason to think it does do something. I mean, it's hot. I'm not going to get my whole finger right down on there, but I'm not seeing any smoke yet, which is nice. I'm sorry I've got, like, spooky cam on you here, but, like, I want to get in on this action, too, and see what's happening there. Yeah, zero smoke so far. Did I put the... Oh, I didn't put the lens back on. That's fair, Chris. Yes, I wonder how much that affects things. So clearly, like, you know, some more science to be done in a more rigorous fashion. I'm also now putting the lens back on while it's hot, which is sort of an exciting prospect. I'm going to use these pliers here. Get in there. I really do want to get this on right, because when it's on right, the plastic, like, presses right up against the LED. Ah! That's first burn. Whoever had 941 Central on the pool, please come collect your prize. All right, so there's the lens back on the thing. All right, let's try this again. If this starts burning very quickly, Chris, I'll be very interested. Like, the lens may be significantly affecting, like, airflow and heat dispersion. David's first burn. The other one was, I guess, more of a warning shot from the light. No smoke yet. I feel like it took a good, like, 20 seconds last time. Not that it moving would do much, and not that I want it to only not burn when it's moving, but I wonder if that would improve airflow at all. I mean, certainly having the other half of the body off is improving airflow. I mean, I don't think there's a lot of convective cooling going on here. It's also, so, like, I don't know if you can see down in there with that blazing light. So the wires are kind of, like, causing it to float a little bit, and I think the only part that's touching the plastic now is maybe, like, one little corner of the star down here and the lens itself. So I don't think there's... And, oh, hang on. Oh, there was a little wispy. There was a little wispy of smoke. Like, right after I tapped it. Maybe I bumped something into some plastic here. Yeah, not a lot. So what I guess I'm learning is, like, heatsink, yes. Heatsink, yes. But also... Oop, there's a wisp. Oop, and desoldered. So maybe some of that smoke is flux burning off of the solder areas. That could easily be. Like, unburnt off flux could be, you know, dissipating from the circuit board. Or maybe solder mask around... I mean, the solder mask seems unlikely because it's a high-temp PCB, so presumably it's a high-temp solder mask. But it could easily be flux. So that's an interesting issue to overcome, right? Like, there's there's not so the answer to all of this, right, would be better heat sinking, right? Because if the star is getting up to several hundred degrees C, that's not going to be sustainable for any number of reasons, right? You know, by the time it's honestly, the desoldering is kind of acting like a little mini like thermofuse in there. Like it's a little thermosensitive breaker that if it gets too hot, it just pops right off. At least in this configuration, right? Not you know, purposeful, but interesting. But cool. I mean, it didn't burn down. It didn't burst into flame. It just desoldered. Ooh, it's hot, yo. I mean, like that's probably 150, 170 F, maybe, yeah, thereabouts. I'm not going to touch any of the metal bits, but just the lens is quite hot. The plastic is quite warm, the PLA, but it's not deforming at all. Like I would say that's similarly like probably 200 degrees Fahrenheit maybe, but it's not to the plastic point, like the deformation point of the PLA itself, which is good. Yeah, that's still rigid for sure, which is good. I mean, that's what we want. Why don't we pop this lens off and see if there's any discoloring or anything on here? Yeah, I mean, so there's the let's see if we can get this to focus. So the yellowish spots on the star there are just flux that were part of the soldering process. You can see, you can see this other wire almost desoldered itself, like it was liquid and going. And then the first one went and it cooled off, but it's just hanging on by a thread. Like I didn't do the best solder job on this, but I did better than that. Wow. All right, so things we've learned tonight. Heatsink, yes. Hot, bad. Airflow, maybe. Consider limiting current. Need lid to fit better to body, or think about clearances. Need body to be taller so that the power module can actually fit in the darn thing. And rethink connectors, maybe RJ11 is an option, or locking DuPont or other things. But yeah, clearly I was so hopeful this would be the thing because these are so cheap and they're so slim. It's just not like even to hang these up. We're not going to get to the little bit of trust tonight. That can be for another time. But even to hang it up on an environment you control, like that's just not a sustainable connection. But within all that, I think the goal of version 0.9.1 was for me to learn about what it means to build these things at any kind of like intermediate scale, right? So like I've been doing these prototypes in 1s and 2s since the start of this project, and this was the first one. I ordered a batch of 10 pre-assembled circuit boards, and if you watched my other video, you know how I screwed that up, but that was the goal of this, right? Was to learn something new about like what it means to do these at scale. A key takeaway, and this is something I knew before and was pretty cavalier about, is like, you know, I didn't think through all the ramifications of making late design changes, like swapping from one power converter to a taller one, and I didn't build out a full prototype before I printed all 10 sets of parts for these. Like right now, the other 9 of these that are too short are not really, you know, they're going to become, you know, interesting paperweights, essentially, which is fine. I mean, that's what 3D printing is for. It's plastic, it's cheap, it's biodegradable, so it's not bad. But that's like definitely a lesson learned. You know, obviously check your bill of materials so you don't end up with LEDs in place of your resistors. A key lesson there. But I feel like this is a success. And when I put this next to, oh, that's still hot. When I put this next to, you know, version 0.8, you know, not a ton of mechanical differences, but things like, you know, the attachment points for the other half of the body work significantly better. You can also tell this one was printed on my home printer and it has some chatter. This one was printed on the Prusa and it's very smooth. Like the body attachment method, I'm fully satisfied with. Like that works really quite well. The new spacing in the back of the body to get the servo wires out, I'm really quite happy with. I think the new screw attachment point for the PCB down to the base, I would like if my screws would ever show up. So I think this is a good success. I think we'll call the revised body version 0.92. And we'll get that spinning, because I think I have enough of these parts that I really would like to assemble all 10 of them and hang them on the mini truss and like borrow somebody's Nomad key and DMX node and like do a light show and limit the maximum output power to probably like 50%, just so they don't burn, but no one needs to know that on video. And then move on to like, okay, so like that's version 0.92. What's the next version after that? But I think this is a really cool success. And this was really fun to do live with y'all. Like I had a blast. I had a blast burning my fingers. Chris says, why hold on the head instead of a slot at the edge of the half? Chris, can you say that again? I don't quite understand. Why a hole on the head instead of a slot at the edge of the half? Oh, are you talking about the ventilation holes here, Chris? I think that might be what you're talking about. Oh, for the cable? Yeah, so that was just an effort to try and maintain some like mechanical stability through this section. I also wanted it, I really wanted to try and keep this half purely aesthetic. And if this slot is cut all the way through, then the cables start sort of pressing on this other half. I like the idea that and maybe it's impractical, I like the idea that for servicing the inside, you just have to boink, pop this head off, and now all the rest of it is still attached inside there. I can definitely make this slot bigger. Like I've been a little precious about how large that slot is, and it can be bigger than this. It doesn't need to be that small. So I don't know. That's basically why. Oh, Palmer has a QLab. Oh, I've never played with QLab lighting, but I would love to someday. I don't know if like in theory, my little where is it here? My little like this thing is essentially equivalent to an NTEC open DMX interface, or I guess really, this is an open DMX interface. I don't know if QLab supports something like that. QLC Plus, I think have I frozen? Hello. I think that webcam has frozen. Did it seem like it froze for everyone else? It certainly, I swear I don't look like that guy over there. He's looking kind of derpy, but that's bad. Hang on, let me restart that so I can close this thing out. Let's see if I open up this setting, deactivate, reactivate. There we go. And of course, Logitech drivers just suck. So when you deactivate and reactivate something, you lose all of like your white balance and everything. So just for the sake of closing this out strong, I'm going to readjust those on the fly because I have feelings about how my face looks, and we'll call something like that more good. Sorry about that. How bizarre. Yeah, from burning to freezing in one show. Yes, the subtitle of this, when you find this episode on Netflix, the subtitle is From Burning to Freezing, Demilight 9.1. I love it. Thanks, Joe. Yeah, thank you for the heads up. I don't know how long it was frozen before I noticed, but that's unfortunate. Yeah, let's call it there, y'all. This was a cool experiment night. I had a blast. I want to do, I think, more of these like casual building nights. Yes, Nate, great question. So next Sunday night will be our regularly scheduled electronics bash, which for those who haven't checked it out before, I do bi-weekly like classes it was an Arduino programming class for a long time. Now it's a Raspberry Pi programming class. Next week, we're going to be building a spooky pumpkin face. It's kind of a culmination of the things we've done over the past few weeks, but it's going to be controlling servo motors and probably some sound playback. And if I can think of a reason why, it'll like reach out to the internet to do something, because we did a whole week talking about internet interactivity. Not quite sure, but like we'll just build something fun with a Raspberry Pi. If you have a background on it, great. If you don't, I think this will be a fun week to start out as like a what can Raspberry Pi and Python do together. That's next Sunday night at this exact same time, 7 p.m. Central, here on YouTube. If you subscribe and ring that bell, I hate myself, you'll get a reminder when that happened. If you have questions in the meantime or just want to say hi, I'm on Twitter at JeffersGlass. Find me there. My website, jeff.glass, is where my blog is. I don't post on it that often, but I do update the electronics bash page there. It has all like the slides and the lesson plans and the code that we use, which I think is neat, especially if if you're not as familiar with like Python and programming code. If you want to follow along as we go or reference back later, that's maybe a useful resource for you. And then, so that's this coming weekend. That'll be the 24th. The week after that, which I believe is Halloween, right? The next, the next Saturday is the 31st. So the first will be the one after that. We might do one of these fun casual streams with another project. I don't know if it'll be Demilight. I can't imagine I'll have a new version to demo by then. But goodness knows I got a lot of projects on the bench that could use a little work, and it's a fun excuse to like come out and like chat nerdy with y'all. Maybe we get a little deeper into like 3D printing at some point. You know, maybe I finally finish some of these ham radio amplifiers I've been building, or the DMX IR transmitter. That's a cool project that kind of got put on hold by COVID. In fact, I still have one at the Goodman that I need to retrieve someday. So yeah, we'll see what happens Sundays after that. But thank you all. This was a lot of fun. Yeah, I had a blast. Stay safe out there. Please, if you're not registered to vote, go do it now. Please keep hydrating yourself. Get lots of sleep. Take care of yourselves. It is a real privilege to be here with you on this Sunday night, and so I hope it is a way of building strength and getting excited and going out and doing really cool, fun things in the world. I'm Jeff. I like you all a lot, and I will see you next week. Thanks, y'all. Bye.